Hey guys, good morning.
Good morning.
Good morning, sir.
Hey, very good morning. So everybody in?
Yes, Adam.
Okay, give me 1 minute. Let me start the machine. Okay. Is my screen visible, guys?
Yes, sir.
Yes.
Yes, it's visible.
Okay, awesome. So, all right, just to recap, as today we were completely looking into the so-called Terraform fundamentals. So fundamentals is all about understanding how does the Terraform workflow happens, and you know, basically what are the configurations that you have to give and blocks that you would have from a high level. So far what we know is you would have a provider block which specifies the service provider to which the Terraform will be connecting, and that's basically the plugin which internally it will be using for each service provider. And then for every service that you want to access, so we have something called as a resource block. So you can have more than one resource block depending on how many services that you want to manage. And for each of the service block, you would have a specific or a unique name and a type of the resource, which is again particular to a provider. And then if you have a dependency between these resource block, then by default, if there is no dependency, then Terraform would execute all the resources in parallel. However, if we try to specify the dependency, and then the dependent would be first executed, following by the actual resource block. So in that way, there are two types of dependencies, which is implicit and explicit. And then we also understood something called as a taint, wherein any point of time, if a particular resource has been marked as taint, Terraform will go ahead and recreate the particular resource forcibly. Okay, and another thing that we understood is what do we mean by variable? So once again, that's a new block, and a user-defined variable will be specified as a separate block, and there are three types basically: the default, which is scalar, and then you have your list and map. And either you can define all the variables into the same file, or this is where we also understood as a best practice, have main.tf to focus majorly into the resources that defines the state, and supporting it any variables that you want, you can put it up into a separate file called variables.tf. Okay, and every time you have to execute, do a Terraform validate, and then do a plan and try to review the changes, whatever you have done, and then go ahead and apply. Okay, so this is more about what we understood yesterday. Okay, so before we jump to the next topic, any questions or doubts on it?
Adam, I didn't understand how this is much more efficient than the traditional way of creating it directly via AWS. Because here we are dealing with, even though we are not mentioning how to create a server, or let's say what we downloaded an image step by step. We just said that we want it, we desire this, but it's again we are dealing with CLI, command line interface, and command line interface is anytime less efficient than GUI in terms of time saving. So I didn't get
No?
this part, how it is more efficient than the traditional way.
Okay, so now tell me, I just give you this requirement where I want to make sure that the machine is available, which sounds very easy because for that, what you're going to do, you will go to your AWS console and basically you have to connect and then go to the particular service and then check whether the machine what you have is available. But if I tell you that I don't just need a machine, but I have certain properties around the machine that I need to make sure, which is just one small part of your infra. So then you have to go through your configurations once again in the AWS console and try to find out everything is exactly what you need. So do you think is that time consuming, or let's say you put all those things whatever that you need, which is just one time effort in the beginning, and everything is being fed as a file, and then you just log into a machine and execute a CLI. And for that, you don't have to even log into that machine. So we also have a lot of automated tool where instead of you going to the machine, I can write some automation where on a click of a button, I can execute Terraform automatically. So that is also possible. So in all these ways, we are not looking at just entering a command, but look at the things after that, wherein when you have all your configuration defined as a file, so this is where we are telling as infrastructure as a code. It's very easy, right? Where all you have to do is one click of a button where you can execute something like Terraform, which will manage your entire infra. The same thing, if you have to go to AWS console, now tell me how much of time that you will take just for one machine. So I want you to check whether the machine is created with the proper, the group. I want you to make sure that whether it has a proper availability zone created, which is needed for you, and does it created under a particular region. And I also want you to check whether it has a particular security group. Okay. And then you also need to check whether it has a proper key associated and a proper hard disk associated. So tell me, if I give you this AWS console, how much of time do you take just to check this? Do you think you can do it easily? Now, the same, as I said, this is just one part, right? Now, assume I'm not interested in just one machine. For me, my infrastructure involves to ensure that from a top level, I have a VPC, internet gateway, and then I have a root table, and then I have an ACL setup, and then I have a security group setup. And then further inside it, I might have a database, a machine, or load balancer. All these things together is what now I say infra. Okay. And now, if you have to do all these things, whether you have to create it or whether you have to every day go and see and manage whether working or not, how much of time that you will take. The same thing, if I put everything as just a file as a configuration, and all I'm going to do is just enter two commands, Terraform plan and Terraform apply, which will take only few seconds for me, and I don't have to do everything manually. I can automate it and I can sit back and just see what is happening. Whereas when you do everything, there is a manual intervention needed, and this is more procedural, which is what we call it as more of imperative method. You have to sit and do one by one. Can you see whether your VPC is configured properly or not? At the same time, can you see security group? No, you have to go through one by one, right? So think from a larger perspective. It's never ever that CLI is time consuming. CLI is the best for automating. UI is just for user friendly, wherein you want to get certain things by click of a button. It's more for visual. Okay. So data visualization is where the dashboard comes in. Getting
From the
it?
larger perspective, right, the CLI would be better anytime. Correct. I get it.
Even on a smaller perspective, it's not at all that dashboard. You are just thinking on this page, that's it. But now I'm telling, can you tell me whether a machine is properly created? And like I said, I need these many properties. How do you check? You need to go and check
One
on
by
each
one.
and every property here. Yeah. So which is better? Is this better wherein I just take one particular command and I just make sure my file is available? Maybe for the first time I'm spending time, but now you ask me whenever I want to do the check, I will just go ahead and enter the command. But if I ask you, hey, daily your job is to do this. So how much of time that you're going to spend here? Whereas what are you doing efficiently is the other way. So that is where in DevOps, the best practice that we say is we don't want any manual intervention. So we need to make sure things are automated. And for that, in the management of infrastructure, we need to convert our infrastructure need as a code. And the same, we are not talking about just one machine. Like I said, the whole infra is huge, right? And any point of time, things can scale. So for all those activities, you should be ready because no one would be hiring for a person to just check for one machines. I have a couple of things that I have to do. So for all this activity, you just think dashboard is just for data visualization. And I have to sit and monitor. This is not just one activity. Again, like I said, whatever that you're going to work on infra is just one part of your day-to-day responsibility, but you would have other things also to do. So if you keep spending time just saying that, hey, I have a very good dashboard, I want to come here and click, think how many other things that you do, because eventually an organization now is looking at people who can take multi-hat responsibilities, right? So that's what the whole logic of DevOps coming into the picture. So the traditional method and the DevOps culture is we don't want someone to do a single activity, okay? Because you're not thinking of doing any automation. Whereas now there is no restriction on who should do what. Anyone can do any kind of work, provided you know how the automation. And that is where whether you are a developer or a QA or even a support engineer, right? Now, if there is a requirement for you to create an infra, if you know how to write or define your infra as a code and you have certain permissions for that, it's more than enough for you that without waiting for a separate admin to get the things, you can create your own infra. So this is where for all this, your dashboard is just merely a point for visualizing. Okay, so never ever compare with CLI with this. Okay,
Yes, yes. I get it.
okay. Any other questions or doubts?
Adam, hello.
Hmm?
Yeah, so
I
yesterday
can
I
hear
closed.
you.
Yeah, so yesterday I closed everything and tried to like redo everything that you taught. So when I was doing connecting it to MobileStem and doing the AWS.sh thing, I was not able to like validate. I was not able to plan that. When I did the Terraform plan thing, it kind of showed me that it credentials not found. And when the same thing was done by one of the friend in the same group, it like working on his system. So why is it so if you can?
Yeah, so there's only two things that you have to debug. One is your AWS credentials correct? Okay, so that is one thing you
Hmm.
have to cross check. And the second thing is if you are trying to use the method that I showed you, then you just cross check whether you have the environment variable created properly and there is no
Hmm.
typo where you have copy paste. So if these two things are there, I think pretty much it should work. Okay, so I would ask you to just go back and see those two. So it cannot be like
Okay.
it works in one place, it cannot work. The only thing is, have you copied the credentials properly? And while you're entering, have you made sure there is no typo and you have entered? So this is one way. If not, you
Hmm.
can also go ahead and if you have the AWS CLI, you can just say AWS configure and enter the same. And internally, when you run this, what happens? The AWS configure, it will create a file called credentials file under your home directory under .aws folder. Okay. So even if you have that, Terraform will automatically read. So just try to see if you're doing both of them correctly.
Okay.
Adam, were we supposed to keep the instance we created yesterday? Because I terminated it. If we need it, can you give me 5 minutes to recreate the same?
Yeah, there's nothing wrong. It would hardly take 2 minutes for you. Yeah, create a new machine and just install Terraform. Now that's the
Shall I install
beauty.
Docker
You don't
too?
have yeah, it's good because few more examples I might take back both. So better install it.
Okay, please give me 5 minutes.
Yeah, you can just run on the background. Okay. Any other questions?
Adam, just to confirm, like this Terraform training is supposed to get over tomorrow, right?
Yes.
Okay. I just need to confirm it to my manager. Thanks.
Okay. So you want to stop it early?
No, I just have some work, so I have to
No,
start
so
it from.
actually, it's that it's just for 3 days, right? So we kind of get into the system and get actually understanding, and then by the time we could start understanding things, the training is already over, and we are into some new thing. So it's like that.
I understand. Unfortunately, yeah. So this is not things like how we used to have earlier, right? More things. It's good. In fact, you guys are getting a lot of training. The only thing is you just have to, initially it might feel a little hard, but once you get used to the system, understand, then it'll be pretty easy. I mean, that's the whole point that I want you to understand, especially when you take things like AWS and others, there's too many things. You cannot just jumpstart and become an expert. So what you need to do is understand the core logic, the concepts, how it works. So that is going to act as your building block. Anything that you learn, whether it's in DevOps or another way, don't just try to sit and learn everything in 3 days. It will never happen. But understand more in a way, how you can get familiarized with the concepts, the building blocks of the fundamental things. With that, later on, if you have any, advanced tasks also, you just have to spend a little more time and try to search for the exact, module of the function, and you will be able to achieve. So that's the only best way that you can learn everything in a faster time. And even that's the reason I'm just trying to go. Yeah.
Yeah, so if we are asked to kind of do the certification related to Terraform by the in these 3 days training, is it possible to clear
Definitely.
that?
I'll make sure you are at least prepared for 75%. Okay. Now the remaining
Because we are
25% is
already
you.
okay.
That's what I'm
Okay.
saying. Logically, whatever is needed on the certification, I'm saying everything is there. But it is not that, as soon as you finish 100%, you have to go back and take. It would take a little more reading for you because of various reasons and, the time bound. We'll try to cover, but few things you might not be able to understand or you have to recap. And certification, they'll be always asking a little deeper also. So always go back with what we have seen and explore little more options. Take some mock sessions, some questions, and then if you go back, most of the thing are already available. So that's where I'm saying definitely you'll be ready. But the only thing is, those 25% depends on how you go back and rehearse and just try to brush up all the concepts. So from the conceptual perspective, whatever is needed will complete, and that is where I'm not going to just take one example and show you, right? If we do that, you will never understand and you will not be able to take the certification. So instead, I'm doing the reverse way where we're going with topic by topic, try to understand what it is doing and take an example, and not just only from certification, but also when you go back, like if you say, yeah, I'm certified, but given a scenario for a real time, if you don't know how to think, then it will be difficult. So that's where it's more of a scenario based, which always I would like to do. And that's where I'm trying to keep. Now, post all this, when you just get a scenario, you should be able to literally get back, okay, for this scenario, I think this is how I should be doing. And these are the blocks I need. And then for each block, what will be the exact keywords? So that's just a few minutes that you have to spend and try to search and get it. Other than that, most of the things would be there already. Okay, so that's what I'm just trying to cover in that perspective. Any other questions? Okay. Now, since we have got familiarized with the fundamentals of Terraform and the workflow, let's get a little deeper into the advanced topics. So far, we were seeing the provider block, and after that, the main block which we had was resource block. Okay. So what is that we did using resource block? So if there is a service in AWS, for example, which you want to modify or create or destroy, then you are using the resource block. Okay. So based on that, now if you want to create a machine or update a machine, create S3 bucket or update a bucket, create a load balancer, update a load balancer, whatever you do. So for all of them, you have a resource block. Okay. But for certain activities, you need sometime Terraform to connect to AWS or any service provider and fetch some data, which is going to be only for read-only purpose. Okay, that means there is already some data available in your service provider. Now, if you want Terraform to connect to the provider and not modify or change or create or delete, okay, instead, if you want Terraform to just connect to the service provider and fetch some data, okay. So when I say fetch some data, it is going to just collect some data which is already available in the provider, and that is only for read-only purpose because you are not going to collect and modify. Suppose if you have that kind of requirement, then your resource block will not be suitable because the default behavior of a resource block is on a service provider, it has to either create or modify or delete. So that is what it is going to do, right? Which is actually something called as read write. So it is reading something, and based on that, it is writing something into AWS. So when I say writing, so creating a machine, modifying a machine, deleting a machine, all these things are some kind of write permissions. But if you have any scenario in which you want Terraform to connect to AWS or service provider and only fetch the data for read only, that means there is already some data and it is not going to do anything to it. It is just going to fetch for read-only purpose. Like what? So if I just ask, hey, can you just show me the list of machines that you're working? Then for this, you're just going to get the list of machines that is available depending on some scenario that you're giving, right? Like I want to list the machines under a particular region, or I want to list the machines which a particular type, right? Like that I can do. Or I can say, hey, can you just list me all the availability zones that you have? Or in IAM, you know that there are policies, right? So what if I just want to read some policies? So this is where if there is a need where you want Terraform to collect some data or fetch some data which is already available in your cloud service provider, and that is going to be only for a read-only purpose, then instead of using resource block, so there is a new block that would be using, which is called as a data source block. Okay, we also call it as data block. So as the name says, so what is data block or data source block? So whenever you want Terraform to collect some data which is already available, okay, because think back, what was resource block doing? So resource block is not going to just collect, It is reading, but if the state is not based on what you have told, it's actually doing some write permissions, right? So it is modifying things. Whereas if something is not there, it will create. So now, whenever you want to just collect the data for some activity, wherein you don't want to change anything except whatever is available, you are going to just collect and read the data, okay, only for read purpose. So for all the scenarios, there will be an additional new block which we have to go through, and that is called as a data block or a data source block. And once again, similar to how you have different type of resource block in AWS or any other service provider, depending on what type of data that you want to collect, there are different data blocks also available, or the types of data is also different. For example, collecting a list of machine. So there is a specific type of data. You want to collect the availability zone or list the availability zone, then there is a specific type of data, or data type is different. Okay, so just like any other block in Terraform, to define a data source block, you're going to say data and followed by the type, which is where it is specific to the service provider. And then you're going to give a unique name to identify this block. And followed by that, you're going to give what are the different arguments in a key equal to value combination. And in that, you can also use additionally something called as filter, so that you can exactly remove all the unwanted details, and you will be able to get only the details what you want. So like I said, for example, I want to list a machine. If I just say list machine, it will give me each and every machine available. Instead, I can filter saying I want only those machine which is running in a particular region, or which is running with a particular security group, or which is created using some type like T2 micro or T2 medium or T2 large. I can say in that way, or I can even simply say, give me only those machine which is running or stopped. So it's all about different combinations that you can give. Now again, the question comes, this is where, how do I get to know all these things? So if you go back to the Terraform, so in the website, okay. So Terraform has a lot of providers. So you can just go to the terraform.io. Now over here, if you just scroll down, there will be plenty of documents available. But if you want to specifically get to some, you can just easily go to that. Okay, so now this is the provider for AWS. But however, for each of this provider, you would be having a lot of blocks. Now here on the left hand side, whatever you see, all these are a service in AWS. Okay, and under every service, for example, if you say EC2, now under this, you can see it would have something called as resource block and then data source block. Okay, so now if you want to do anything with your EC2 machines, then in that, are you going to do some read-write permissions or only collect the data for read-only permission? So based on that, you're going to use different resource block or different data source block. So here you can see what are the things that you can do specifically, and the same way now the data source block is also going to be different. So this is where exactly you need to identify what is that you want to define as a state, and based on that you just have to go to this and you will have all the details here on what and all arguments that you have to take. So this is where I was saying it's only about a little more practice where you try to take some examples, and in that you can find out what it is going to do. Okay, so just start referring to this page, which is terraform.io, and there you will see all the different types of providers. And if you're focusing more on AWS, and for AWS, you can see for every service you will be having resources and data source block. Okay, but coming back. Now, let's take an example and see how it is going to work. Okay, so what I'll do, I'll simply take an example here. Okay, before that, actually, I missed one topic. Okay, so probably I'll complete this and I'll show you. So let me start the machine. Yeah, for those, someone said you're going to terminate. You don't have to terminate, just stop the machine, and whenever you want, you can just start it back. Okay, the machine is up. Let's connect. Okay, so here I'll just create a folder called data. And here, what we will do, we'll just try to take this example. Okay, so in this, just to understand, there's a provider block and I don't have any resource block. Instead, all I'm giving is, I'm giving a data block. And in this, I'm saying to use a data type, which will help me to fetch the details of availability zones. So this is specific to your provider. Okay, so that way, this is a keyword that you need to search from the registry file. Okay, however, example is just a name. Now, if you go through this block, the only thing that I'm going to say is, show me all the availability zones which is there within this region. Okay, so assume this is just my requirement. Now, it is not just that you are going to do only a data block here, but you would be giving a combination of data block and resource block. But just for now to understand, all we are trying to do is try to put a data block and then let's see what Terraform is going to display. Okay, let me open a file called main.tf. Okay, so what should I do first?
Validate.
Is it correct?
Init,
Or
init.
init. But init we had done already.
Where we have done already. This is a new folder. I just
That
now
is
created it.
okay.
So what should I do?
Terraform init. Okay.
What is it saying? It doesn't know anything. So the first thing what you have to do is you need to do a Terraform init.
Init.
Every time in a new folder where you don't have anything, you have to first do the initialization. Okay. And now we would have that dot folder. That's a Terraform dot folder. And here, once we have the dot Terraform folder, now I can go ahead and say Terraform validate to cross check. Okay, everything is fine. And Terraform plan. Okay, so first, what do you see here? It says your infra is up to date. That is because you haven't given any resource block in your configuration. And the second thing, the data source block is not going to modify anything. It is just going to collect the data, right? That is where it says there is no change in the infra. Infra is up to date. Getting this? However, if you go ahead and say Terraform plan, and then it will try to collect the data, okay, because it's just trying to get. Now in this, if you say Terraform show, because it has collected the data, but how do I see? So anything that Terraform has collected, and it will be kind of storing it internally, and that if you do a Terraform show, it's not showing, right? So ideally, what is happening in this? So Terraform has collected, but where is the output? Because unless and until there is no state, it is not going to display anything. Because the values which Terraform collects, it's just a read only. So it will be available only until the execution of Terraform. Okay, so it doesn't store it anywhere. So now comes the question is, how do I see that? Correct? Because the whole purpose of collecting is within your configuration, other resource block can refer to this and it can collect the information. Okay. Now this is where let's go ahead and apply. And you should be seeing now, since you have applied, Terraform is kind of connecting to the provider and it is collecting the information. Okay, and what is the information that it has collected? This is the information where you had asked for running a data source block to get the list of availability zones, and you can see that this is what you have. Okay, now look very carefully. The names, what you see here is a variable which is trying to store the information. Now, what type of variable is names?
List.
Yes, because you can see it has a square bracket, which indicates that it is a array or the list. And the same way here it is displaying, right? So this is the value. So now, if you want to retrieve a value specifically from a data block, then what you should be doing is particularly, you need to say similar to resource. Now, instead of the resource, the interpolation will be what? Data dot the type of the data dot the name, and then followed by the attribute of what is that you need here. So in that example, suppose if I want to access this zone ID, then I should be saying data dot AWS availability zone dot example. Okay, and in this, what we are going to do is, if you want to get this, then I should say example dot zone underscore IDs. However, since it is a list or an array, if I just say dot zone underscore IDs, it is going to give me all the three. But out of that, if you want a particular value, then you have to say square bracket of 0 or 1 or 2. Okay, so that is where your variable concept is quite necessary. Okay, but now still the question comes is, how am I going to print this value? Because here, if you see, Terraform show has captured and you are using it. But within your configuration, if any other resource block wants to use it, then you are going to refer in this fashion. So the data dot type, the name, and the exact attribute, so that now for other resource, the value, whatever the data source block has collected, will be available. Okay. Now, in this, there is one more small variable that we didn't see, which is output. So yesterday, we saw that when a user has to define a variable, that is a user defined variable, we will be giving a block called variable block, and then you are going to set the value, right? But however, now when there is a variable for which the system has to generate and update some value, then those are called as output variables. Okay, so basically in variables there are two types. One is user defined and the other one is what we are going to ask the system to extract a value. So that way, anything that you are defining the value, you're going to define it as a variable block. Whereas if you want to capture some output from a certain data source block or from another resource block, then we are going to use what we call it as output variable. Okay, so the difference is, instead of starting the block with variable, you're going to start the block with output, and followed by the output, you are going to say the name of the variable. Okay, and then within the value, what we were doing in our user defined is either you set the default value hard coded or a user can pass. Whereas in output, you are trying to capture something from the Terraform execution. So this is where you can actually refer to a particular value that you are trying to retrieve or attribute from a particular resource block, and you can just display that. Okay, now quickly to show you this, what I can do, let's go back to Docker once again. Okay, Terraform plan. Okay, so nothing is available. Fine. Now what I want is, I want to get the output of the container's IP address. Okay, so this is what I want. So when I want the container's IP address, how can I get it? So if I go to this resource, so if I say a docker underscore container dot container ID dot, and if you look into this, you would be having something called as IP. Okay, now it's not generated. Okay, so what is that here? IP address. So if I say this as an attribute, then what will happen? It will exactly return me this value. And that, if I capture it using my output variable, then you can use this output variable basically to print on the screen, or it can also be used to act as something to return a value. Okay, so remember these two things. As of now, output variable is just only for printing on the screen. That is what you're going to do. But the other main use case for output is to capture some variables content, or to capture some property from any resource or data source block, and it will return to another function or another resource block. Okay, so when we go through modules, we will try to see all those things. But for now, what do you mean by output variable? It's a variable which will help us to capture some data, and it will be just returning back. Since we are not telling where to return, it will just return back to your console, which is where it will just print it. Okay, so now what I'll do here, I will say it as IP address. However, so docker container dot container ID is the resource name, and in that we will just add one more called as IP address. Okay, now ideally you can keep this on a separate file, or you can also add to your main.tf. So it doesn't matter, but it's always good you keep it separate. Okay, so what I can do, I can create a file, and again the name doesn't matter, it can be anything, because Terraform will read all the .tf files in your current folder. Okay, so I'm just going to put it up, and now when you say Terraform land, okay, so right now it says it doesn't know, because that will be given only after you apply. So let's say Terraform apply, auto approve. So you can see what it does after it is performing, it exactly gets you the data here, wherein this was the output variable. So since we have not told where to return, what is happening? It is kind of returning it back to the console. Okay. And if you do Terraform show, this is what we'll get. Okay. But internally, what did it do? So from the container resource, it exactly captured this. So that is where output variables are meant to capture some property from a resource or to capture some, again, details from a data source block. Okay. So it is kind of printing it, right? Now, when I say destroy, it's not going to do anything. Now, the same, what I can do is, I can also add it to this example here. So right now it was capturing some details, right? So I can put a output variable block and try to capture this so that I can exactly capture some output and I can return it to the console or I can return it to another function later. Okay. So for this, what we can now do, I'll just add this output. Okay. So again, this is just a name. And now what is the value? So the value over here, if you see, I'm just going to say data dot AWS availability zones, which is the name of this data source type. And then the actual name of the block is example. Now out of this, what is that I want? I want only names. So that means when I say names, so if I go back to my data, okay. So I am going to get all this. So by default, if you say names, it will give you everything over here. Okay. So watch this now. So I can just add this. So every time instead of me doing a Terraform show, I can simply add an output variable and it will return whatever the specific attribute you are capturing as a variable. Okay. So Terraform plan. Okay. And Terraform apply. Okay. It's not giving it.
Sir, in VI, you should not give it in inverted commas in quotes.
I didn't get you. Mean to say this double quotes? Yes, thank you. Okay, so it's kind of taking it as a default value. But anyway, you can see it kind of collects. Okay. Anyway, so now coming back to the point. So data source block is one where you will be able to get or collect some data which is only for read-only purpose. And anytime, remember, output block is another variable which is not user defined. Now this is something which we will be using to collect some data from a resource which is managed or from a data source block, which will be returning. Now this return by default will be returning it on to your console. However, if you want, you can also return it to another function later. Okay, this is just one example. Now to follow up, I'll show you another example. Okay, so here what we will do, we'll try to list some machines. Okay. Now what I want to do is basically go to the Mumbai region, and in this I want to collect the list of machines. So for this we are going to use a data block called AWS instances. Okay. So now here I'm just giving a name for it as test. Now in this I'm telling I want a list of all the machines which is running and stopped. Both I want. But out of that, I'm trying to apply some filter. So the first filter I'm saying is, give me those machines which are either T2 micro or T2 small. Okay. So only if these are two, then if it is running and stop, it will give me. And however, I'm also saying, give me those machines which are also part of a security group. Okay. Now here I don't have the security group, so pretty much you should go back and check what is your security group that you have given. Now I'm using my default security group for all this. Okay, so this is the one. Okay, so I have to keep this, but for a minute, I'll just show you what it will do. Okay, and further, what I'm trying to do, when you run this, okay, I don't need this. So when you run, it is going to get the data, but see what will happen now. Okay, I have one second, excuse me. So if you see, what happens is whenever you are trying to run a data source block, I told this particular point that only if there is a data existing, it will be returning the value. If not, it will give you an error. Okay. So right now, there is no such security group with this name. So that is where it is going to give you error. So whenever you are using data source block, make sure you are using all the right values. Okay. So this is the behavior of Terraform. If it doesn't find a matching value to read, then it will be giving you an error. Okay. So that is what I wanted to show. So that's the behavior of Terraform. So you need to make sure that whatever the data source block you are using, it is going to get some value. Okay, you can see now it found out and it's trying to get you. And here, let's go ahead and say Terraform apply. Okay, so since we have not given any output, so it is trying to show, but if I want an output, then I should be knowing these details. So that's where run a Terraform show and it will give you the list of all the machines. So you can see these many machines are available, which is matching my criteria inside the security group. And it has a machine of either the type T2 micro or T2 medium. Okay, and if you go back here, you should be able to see those. Okay, so you have these many. Now, okay, so out of this, there are a few machines which is not displayed. So here it says 1, 2, 3, 4, 5, 6 machines. However, in this, I have 1, 2, 3, 4, 5, 6, 7 machines. Now, why is it not showing one machine? That is because one of the machine here, because I have a machine which I'm using it for Kubernetes. And this machine is not either a T2 medium machine, nor it is a T2 micro, okay? Because for Kubernetes, you need minimum of 2 CPUs and 4 GB, okay? So that's where you can see the machine type is T2 medium. And because of that, my filter is not matching it, or basically it is filtering it out. So all the remaining machines are being captured, okay? So that way, remember, the data source block will return a value only if there is a pre-existing data. If you do not have, it will give an error. And second, it is meant only for what? Read purpose. It doesn't do anything. So now if I want to add a particular output block, then here I can simply go ahead and say output. Okay. And then you just want some name. So I can just say instance. And here I can just say value. And now you want to capture from the data source block. So we'll say data dot, okay, and then AWS underscore instances dot test dot, what is the attribute that you want? So out of this, if I want the private IPs, then I can just say private IPs, or I just want the IDs, then I can just go ahead and say IDs. If you say IDs, then this will be printing. Okay. Yeah, can you guys try this? And before that, any questions?
Before giving the output block, we should at least once run the Terraform using the data block, because we don't know no, what all key pair values are is it gonna return. Like in the prior example, we didn't have any clue it will return a key with value name, or here the same for private IPs, right?
Exactly, but it's not always, because it's just for the first time, right? From next time when I know, I can just run. So pretty much when you're defining it for the first time, obviously you would not be knowing. So you can pretty much go ahead and do the plan and try to find out, and then try to add everything. So this is where you develop, okay? Because all these things, we don't call it as writing, we call it as developing, because you can't just do everything in one shot. So you need to understand everything and then, but yes, if you don't know, always try to get the data and then try to put the variables accordingly.
Yes.
Can you guys try it and let me know? I just pasted both examples. Okay, so like I said, you can either go ahead and give everything, and if you want a particular index, then just go ahead and 0, 1, and this will return you exactly the attribute. So this is where you need to know what you're capturing. Okay, so if it is just a string, or if it's just a scalar variable, you are going to just say only this. But however, if it is a list, then you are going to give in the square bracket the index. The same if it is a map, then you need to give the key name. So how will you know? So this is where it's all about practice, but you have to first look into the output and see what are the exact values that you're capturing. And based on that, you can retrieve exactly. Okay.
Yes.
Yeah, try out both these examples and see how output is working and how the data block is just connecting, and it doesn't change anything. It will be just displaying only the content.
Yeah, it's working for me.
Hey, have you guys tried?
Yes, it's working. It's done.
Everyone?
Yes, sir, it is working.
Yes, it's
Okay,
working.
cool.
Yes, sir.
All right. So yeah, so now we know when we say data source block. So it means it's only for read-only purpose. Okay, so going forward, understand for every service in a provider, you would have a resource block, which is read-write, which is the one which is going to actually change all the state, whereas the other block, which is the data source block, which is meant only for reading the data. And that would work only if there is a data which is already available or existing. Okay. Okay. Now, there is another concept called Terraform state. Okay. So I want you guys to pay little attention here. So now when you run Terraform, what exactly happens? So how does it know that the infrastructure is up to date or it has to update or it has to delete, right? So how does it maintains everything? So this is because every time when you run your Terraform apply, what it does is it creates a file locally on the same directory, and in that file it maintains the complete state whatever it is captured. Okay, and for the first time when you do a plan, there is nothing available. So this is where what happens is you need to make sure that you have a separate directory for each of your configurations, because what will happen when you try to do a Terraform plan, it not just reads your configuration file, but it also reads the state file. Okay, because the first time whatever the state is available, only with the difference between what is there in the state file and what is that you have given in the configuration, it will try to find out the difference. So when you start with, if there is no output file which is storing the state, then Terraform plan will initially say that, okay, I don't find anything, so let me go ahead and create it. And then when you say the Terraform apply, so whatever the changes it does, it will be going ahead and storing the output into a file called terraform.tf state file. Okay. Now, this is a JSON file in which it will be storing the content. Now, the next time when you say Terraform plan, it is going to read the current state of your infrastructure from this file and then compare it with your desired state in the configuration. And based on that, if there is any difference, it will be telling you what to do. So that way, this file is very important for Terraform because this is the file based on which it will be maintaining everything. Okay. However, if you try to do a Terraform apply second time, then it will not directly overwrite. So it will first take a backup of the current content into a file called that backup, and then it will update, or it will just refresh this. So this is where you would have seen this word a lot of time called refreshing, which means the same file will be getting updated with the latest content. So that way there will be two files. One is the current state, and this is going to be your previous state. Okay. And every time when you do plan and apply, Terraform is going to read this file. And by default, this file will be created in the same directory as where you are executing your Terraform commands and the configuration file is available. That is where it's very, very important for us to understand that you need to have a separate folder. Okay, because if I try to have the same state file for different things, then the output would be quite weird, right? And it will be very difficult for us to work. So that's where I have a separate folder for every configuration. And when you try to run your Terraform, it will create a file locally, which is what we call it as a Terraform state. Okay. And this is where it is going to kind of read the information which is needed. And that's how it decides. And every time when you do a plan and an apply, this file will be getting updated. Okay, so here, now if you go back, okay, you can see that there is a state file, which is what exactly it is trying to store. And the previous content of that or the state is more of the Terraform tf state.backup. And when you do a Terraform show, from where is it getting the information? So that's from the terraform.tf state file. Okay. And when you delete, let's say, the infra or the machine, then what happens? The Terraform state will get updated where the Terraform state file will be empty. And because of that, when you say Terraform show, nothing will be available. So now if you just open this, you can see it's a JSON content. And this is what it's kind of storing everything. And when you say your Terraform show, it reads from this. Okay. Now, let's go back to this Docker, for example. And here also you see everywhere you will have the TF state and here. And when you say Terraform show, now there is nothing. Why? Because if you open this file, it doesn't contain any state here. And that is where it is trying to say it is empty. So every time when you try to run, Terraform will be trying to read this file, and based on that, it will be deciding on what is the plan it has to do. Okay, so watch this now, what I'll do. Okay, here, let's go ahead and do a Terraform plan. Now I don't have the image or the container available. So let's say Terraform apply and auto approve. Okay, so what will it do now? So in the current state, it will update saying that there is 2 resources created, and that is how it knows the information about these 2. Okay, and Terraform show will give you those details. However, since you have applied, it would have taken the copy of this and put into the backup before updating. So that way, if you go to this, what was the previous state? It was empty. So that is where it shows the details that it is empty. Okay. Whereas now here you have the content. Now, what you can do is just to play around, if you go back and try to delete your TF state file. Okay. So what I'll do, I'll move this file to terraform.original. Okay. And when you go ahead and say Terraform plan, what is it saying? So it says 2 machines has to be, 2 resources has to be created, right? This is because since there is no state file available, it is not able to understand. So once again, from the beginning, it thinks that, okay, your infrastructure is not in the desired state and it is going to change everything. Okay. Same way here, if I just move this back up, once again, the same way to the state file actually. Okay, so I'm just moving it as an empty one. So when you do a plan, it reads your current, and exactly based on that, it will be giving you the information. Okay, so this is where it's quite important for us to understand that Terraform maintains everything using the state file. So let me move back this original to state. So now it has all the content. Okay, and if you go ahead and say Terraform plan, it says your infra is up to date because it kind of just reads this text file. Okay, so it is very important that we need to make sure that this file is available. Okay, so anytime if you mess up something with this, it is gone. Okay, so that's where have a separate folder for each of your configuration, and in that what you can do is make sure that you have your state file being maintained. So by default, it will create this additional file called terraform.tf state file. Okay. Now, quickly, can you just try it once? So go to any of your example folder and make sure there is nothing in the state. So delete this file and run your Terraform plan and apply and see what happens. And then you try to change this or take a backup and then try to run and see how Terraform shows the difference. So can you quickly try this once?
Yes.
Yeah.
Yes, it's done.
Sure. Others?
Yes, sir. Tried, sir.
Okay. Cool. Fine. But now let's come back to the same. So we now know that Terraform stores the state into a file called Terraform TF state locally, so that any changes that you do, basically it will be getting updated here. Now, practically, if you are doing more of a development work, so when I say development, I'm not saying development of your program for the application. If you are developing your infrastructure as a code or the configuration files, for testing purpose, what you can do, you can store the file locally in some machine and do your development, validate everything. Now everything is fine, then you will be storing the code into a repository like GitLab repository. Now what will happen post that? Now in production, so let's say that I have a production machine and this is where I want to actually apply. So all I would do is take the latest code, that is the latest Terraform configuration files from the Git repository. And from there, I will just quickly do a clone, correct? So now what will happen? So this way, now, when I try to execute the configuration files, so it will be under a different machine where I'm trying it. But especially when you say production grade, there might be multiple people who is sharing the same environment, right? Because we will have a support team. And what will the support team do? Now, there would be a support team in, let's say, in India at some location. You might also have an office in US or UK or Australia where there are different data centers, and there will be some people who are taking care of things from there. Now, it is the same production environment which they will also be supporting at a different time. Now, what will happen is if you are going to use a configuration file which is being shared, that means assume that I have a team and you have a team. Now you are also maintaining the same infra, even I am also maintaining the same infra, but end of the day, the configuration file should be the same. But if any changes is done to the configuration file, the best practice will be that I modify, develop, and verify, and then I will put into the Git repository or a central repository. So whenever I want to run, whatever changes you have done, I will go to that Git repository and I will be taking the latest code, and that is what I'm going to run. But if I do some other change, then what happens? Even though the configuration file is same, if I clone the repositories to, or basically in Git we call it as a clone, but all it means is you're copying the files to your machine, right? Now what will happen? If I do some changes and I run locally, this state file will be there. However, for the same environment, if you try to have a separate folder and when you try to run Terraform, there will be a different state file. So this is not something which we will be doing in a real time, because in real time for development activities, you can have your own state file. But for a production, we need to have a state file which is more shared, okay? Or what we call it as a distributed file. So the meaning of that is whether I do some change to the infra, it should be going to the same state file so that if you do the change, you should also be seeing the same state, whatever is available, correct? Because when I do some changes, the state file will get updated. And when you try to do your changes on top of it, it should be on top of it. It should not be something separate. So for that, you will be able to know the changes only if both of us are using the same state file. So this is where, how do we make sure that we use a distributed state file so that I can have different configurations wherever I want, but end of the day, we all should be referring to a single state file in production. So that is possible only if you are not keeping the state file in the same folder, but you are keeping it outside in a common location. Okay. So remember, in production, you are not going to have the state file within your folder. So this is where what we can do. There are different places where we can store our state file on a remote location so that it will be a distributed what state, so that you might have different configuration files, but you will all be referring to the same state file. So how you can do that? Now there are different ways that you can do this. Now pretty much if you are using AWS, you can create a S3 bucket and you can store the state file into that. Now Terraform or HashiCorp similarly has another tool called Console, which is more for node management. So you can use this tool to store everything as a state file. Or if you're using more of a Terraform enterprise version on the cloud, so the state file can be directly stored into the cloud. So all of us, when we run, it will be referring to the same state file. Okay. Now, since you guys are using S3, so AWS, let me just try to use the S3. So what we will do now, I want to create a S3 bucket. Okay, and when we are trying to run our configurations, we will tell to refer to that particular state and not to take the default one. Okay, so for this, first let us create a S3 bucket. Okay, so now let me go back to AWS. So this is where you can see that creating everything will be very simple. I don't have to go to console and I don't have to spend time. Now, quickly, what I'll do, I'll copy this main.tf to main.tf dot, I'll just say dependencies. Now, I don't want all the others, so I'll delete this. And I don't want this. Okay, so basically I just want to create one S3 bucket. Okay, and the name of it is Vezvatech. So simply Terraform plan and Terraform apply will just get you that. Okay, so it says it's created. You can go back and refer. Okay, so you have a bucket, that's fine. Now, how do I tell my configurations to pick this? So this is where, so we have another block called as backend block. Okay, now like how you have a provider block, so if you define a backend block, whatever the configurations that you're running from that folder, everything will go to this backend specifically instead of storing it locally. So for that, you need to specify the type of the backend block. So here I'm going to use S3. So for S3, you're just going to give the name. Okay. So what I want you to do is for this state, now I can add this as part of my main.tf, but once again, as the name says backend, what you can create is a backend.tf because the name doesn't matter. Any file which ends with .tf, Terraform will read it. So that now I'm just going to say, this is my bucket in which I want to store the Terraform state. Okay, so that way a key is nothing but under this bucket, it will create a folder called default, and in that it will store the Terraform state. And under which region it is available? It is available on AP South 1, which is Mumbai region. So that's the only thing I'm going to do. So to show you the difference, let me get here. Okay. Now let's go back to Docker itself just to show you. Okay. Now Terraform show. Okay, it has this many information. So let me first destroy this. Okay, so now here, so let me remove all this Terraform files. That is the state file. Okay, so if I say Terraform plan, it should say it is going to generate 2 resources. Okay, that is expected. So now in this, I'll create a file called backend.tf and we'll put this. Okay, so here now, since you have added a new plugin, which is backend, so you need to basically do a Terraform init. Okay, because in the beginning I told you you're adding a new plugin, it needs to know because it's not a resource associated to your AWS provider. This is more of a new plugin to tell how the Terraform should behave. So that is where you need to go ahead and do a init, and you can see it will update the backend. So unless you don't do the initialization, it will not know. Okay, and now watch what happens. So when I say Terraform plan, okay, it's expected that it is going to create 2 resources. Now let's go ahead and say Terraform apply auto approve and see the difference. Okay, so it says that it has created, but where is the state file? So the state file is not there. However, where is the state file? You can now go back to your S3 bucket. And if you see this, you can see it has created a state file under this. So anything that you now modify here, it will be known by picking up the state file from the backend. So automatically it picks up. Okay, now this is where quickly what I'll do, I'll copy this Docker folder, okay, to something called as Docker new. So assuming that someone else is also trying to do the same work, like I said. Now, if I go inside Docker new, okay, so I don't have any files here, but the only thing is I have to make sure that I do a Terraform init. I also have the backend, which is pointing to the same backend and the source. So now everything is initialized. So at this place, if I say Terraform plan, so whatever is the state file, you can see it's trying to say that everything is up to date. Why? Because it's referring to the same backend. So both the folders are referring to the same state file, which is remotely available. And if someone is doing some change here, okay, so let's assume I'll do a Terraform destroy. Okay, so now it is not only this folder, your distributed Terraform state file will get updated, right? Now, because of that, you can see nothing is updated. So now if I say Terraform plan, it will say that it has to create, right? And your Terraform show should say nothing is available in the current state. And the same thing will be there if you go back to this folder, because both the folders or the configurations is pointing to the same backend. Okay, so that's where here also the Terraform show will be empty. And at the same time, when you say Terraform plan, it is going to give you the same output. Okay, so that is how when a production grade, what you're going to do is not to have your local Terraform state file. Instead, you're going to have a remote file which is distributed. Now for that, you can use various methods, but one of the method, like if you use AWS, you can go ahead and just directly use the S3 bucket and store. But just remember, you just have to do a init so that this also gets initialized. Getting it? Got that?
Yes, yes.
Yes, Adam.
Okay.
So here, if one folder has the Docker and the another folder has AWS, so it isn't advisable, right, to have the common TF state file.
See, it all depends on your infra. So I'm just trying to show you a different example. Now, in practical, when you say infra, it could be a combination of all these things. So that's where you need to first understand what do you mean by your desired state for the infra. And based on that, you define your configurations. Okay, so it doesn't matter whatever the configurations you have, but if you say a same state file, obviously you should know what are the configurations that you're going to have for that.
Okay.
Can you try it now? So go back and check what is your state file and then try to change the backend and try to see how it is working. But make sure you create a bucket. Yes, take a break if you want for 5 10 minutes. Hello.
Yes, sure.
Okay.
Yeah, those who have completed, take a break. But again, I'll be there. If you have any questions, just ping in the chat or just let me know. But we'll meet back again by 11:35. Hey, is everyone back?
Hello.
Yes.
Adam, how do we now disconnect this S3 bucket and use the file locally?
You remove the backend. That's what. It'll store locally.
Okay. Are we supposed to do that?
When? I didn't get you.
Now, shall we delete the backend file or shall we keep it?
No, which way are you saying? For your practice, go ahead and delete it. That's all. You don't need the S3 bucket. So you can just go ahead and delete it. So that's where I had this
Okay.
AWS. So I can just go do a Terraform destroy. Yeah. Okay. So it says the bucket has some files. So let me just remove those files. That's the one. Okay. Okay. I deleted and it's just a folder. Okay. So this should delete it now. Yeah. That's the reason I just put it up as a separate configuration. Yeah, once you're done, you can delete the bucket.
Okay.
Okay, everyone else tried it? Oh,
Trying.
okay, just try and let me know.
Done.
Okay, Others, has everyone tried?
Yes, sir.
All right, so let's move on to next topic.
I removed the S3 bucket and then I uh, removed the backend.tf file, but now it is showing as error when I'm doing plan or approve. It is saying to initialize, and when I'm
Your
initializing,
state file still says to delete all the state file and you just do a init once again. It will go off. That's what
okay,
you don't have to do it everything. It's just that if you create S3 bucket, you just delete the S3 bucket and just leave it.
okay.
Yeah, nothing to worry. Okay. So again, so there's a new topic called as workspace. Okay. Now, generally, in any development activity, so when you say workspace, it's a folder where you have all your configurations, right? Or basically all your files. So in Terraform, if you say workspace, it's not a folder that it represents, but it's a logical representation of your configuration files and state file put together. Okay, so that is what we call it as workspace. So eventually, now, whenever you create a folder, and in that folder, when you do a Terraform init and start working, what you get is a workspace in which you have a configuration file and you will have your state file. Okay, and that workspace is always called as a default workspace because so far, whatever that you've been doing, if you go ahead and just say Terraform, workspace show, it'll be just giving you the details that you're working in a workspace. So like if you just say Terraform workspace show, you can say it says default because this is where you have something specifically for your configurations, and you also have something specific to your state file, and both of them are in the location as a reference. But what is the main purpose of this? So what happens when you're actually developing certain things and you might have to test, then you might have to test with different values that you pass to your configuration. Now what will happen? Every time you pass different values and if you try to do a Terraform plan and apply, if you are going to update the same state file, then it will not be easy for you to compare certain things. So this is when what you can do is you can logically have the configurations and state as different copies within the same folder, which is what we call it as a workspace. So ideally for this, what you can do, you can have the same configuration file, but you can pass different values and create multiple state files. What is it? You can create multiple state files. So for that, for each state file, you can refer as a workspace so that your current configuration and a current state file refers to one workspace, which is default. But now what I can do, I can create a new workspace. Is like within the same folder, I can have a separate state file in which I can pass different values and customize this so that on the new workspace, I will be having it is something like your own configuration and your own state file. Okay, so that is how we logically construct it. Okay, so now how do you do that? Now, typically, So far, whatever you are working on your configuration and a state file, all these things refers to your default. So now, if you want, you can create your own workspace within this folder, and you can switch between multiple workspaces. And for each workspace, you are going to have a different state file, so that anything that you modify in default remains only in default. So you can create another workspace, which means another set of configuration and state file. So in that, you're just going to modify everything, and the state file which will be there is specific to it. So this is how you can do something like a parallel development, and you can pass different values and have different state maintained for the same set of configuration. Okay. Now, for every workspace, you are going to get a new state. And this is where what Terraform will be doing is, where will it be storing all the files by default? By default, it stores locally, but that is for your default workspace. So when you are creating a new workspace within the same folder, it will create a new folder on this workspace by the name terraform state.d, and inside this, with whatever the name of the workspace you are creating, it will create a folder, and the state file will be maintained under that, so that this will be the state file for default workspace, and under this folder, whatever the new workspace that you are creating, it will be having the workspace with respect to that, and the file of the, or the tf state file will be with respect to that inside the folder. Okay, so that's the difference. So just to see, so let's go back. So what I'll do here now, I'll just create a folder called workspace, and here I'll copy from the Docker. All I need is main.tf. Okay, or pretty much what I'll do, I'll copy all the tf files from workspace Docker. Okay, so now if I go under workspace, I'm sorry, I didn't do a CP. CP, and I want to just copy. Okay, so I have all these files. Now from this, I'll remove the backend. I don't want to store there. I want to just store locally to show you. And in this, you have the main.tf, so wherein it's the same configuration, and you have the output and the version we have just stored there, right? So this is the only thing. Now here, basically, if I say Terraform init, so by default it's already there. Okay, and let's go ahead and say Terraform plan and Terraform apply. Okay, so it give me some input, and for that I have got these results. So here, if I say Terraform show, so you should be able to get this, and there is a state file available. And this is where now we are working in our default workspace. So if you say Terraform workspace show, it should be giving you that there is one default workspace, and that is what logically in which you are working. And the state file from where you are saying the Terraform plan, it is trying to fetch the state file from the default workspace. Okay, now in the same, let us create a new workspace within this folder. It's just like another logical way where you are trying to tell to create a new content. Now for that, you have to just say Terraform workspace new and the name. but pretty much. If you want to see the complete list of workspaces available in your folder, then you can just go ahead and say Terraform workspace list. And right now there is only default, and this is what you're currently working. Okay. So one is this Terraform workspace list. And if I say new, and just to show you, I'll just call it as test WS, or the name of the workspace is test workspace. Okay. So now watch what happens. So I created, okay, and you have also switched to that. So what is the meaning? If you go ahead and say list, you should see there are two workspaces in the folder, and you're currently pointing to test workspace. And you can also do the same thing by just say show. So where are you currently pointing now? Test workspace. Now you don't see any difference in this, but note it has created a new folder, and inside this folder it is the name of your workspace, and under that there is nothing, but anything that you do now will be reading as a state file from this location, because the state file for the workspace that you have now, it will be kind of, you know, inside this. Okay. Hey, just give me 1 minute. Hey, I'm back. So what I was trying to tell is, for your default workspace, the state file for was this, but when you switched to a new workspace, the state file will be stored into this. And now, see what happens when I say Terraform plan. Do you see? Because there is no state file here, it is saying the two resources are going to be created, right? Whereas we have actually those two resources created, but that was pointing to your default workspace. So that is how, with the same configurations or the file, you can pass different values and you can switch and do some kind of parallel development and testing, which will be very handy on certain scenarios where you want to just quickly test certain things. Okay. Now, if I switch back, so how do I switch back? So to switch back, you can just say Terraform workspace and select, and it will specifically go to that. Okay. So if I want to go back to my default workspace, and I can just say select default. So the workspace will be switched. So now watch the same thing. Okay. And it got switched. And if you say Terraform workspace show, it shows that you are in default. Same thing, if you say list, it will give you everything, but at the star mark indicates. Now over here, what state file it will refer? It will refer here. And because of that, if I say Terraform plan, you should see that everything is up to date because it's referring to this. Okay, just to show you once again, I'll do a Terraform destroy. So whatever I'm doing now, it is going to be on the default workspace, and that points to this state file. Okay. So now here, if I say Terraform plan, obviously it is going to create. So once again, we'll switch to the test workspace that we created. Now here also, now going forward, anything that I store, it will be stored inside this, because we have now switched to a test workspace. Here also, now when I say Terraform plan, there is nothing, but let's apply. Okay, and it will create the resources with whatever the configurations that you have passed. Now I have not passed any values, but ideally whatever we did, it's going to be under this. And now where is it stored? So it is stored inside the Terraform state D folder. You can see it started storing. So now if I say Terraform plan, it says the state is up to date because it is referring to this workspace state file. Okay, and if I switch back to default, what will happen? This will not be known, right? So if I switch back to default here, which is the state file it is referring? It's not referring to this state file. So it is going to refer to the local state file. So now if I say Terraform plan, it says that I have to create everything. Okay. So this is how what you can do is, especially when you start developing, you might have to do certain tests and do some parallel development. At those times, you just need to have multiple state files maintained, right? Even in production, there might be some scenario because it is the same configuration, but for two applications or two products, you just want to maintain it little different with different state. Then all you can do is have different workspace and then just switch to whatever the workspace you want and then run the Terraform apply or plan. So basically it will be maintaining a different state with the same set of configurations. Like for different clients for the same project, you want just a small difference where maybe some uh, assume that in the inbound rule there's a different port that you want to open. Everything is same, but just for one client one port, for another client another port. So that way what you can do, same configuration, have two workspace, and in each one of them you try to pass different values and then just store, right? So that's how within the same folder with the logic of workspace, you can have different states that you can maintain. Okay. And again, this is just for your test. If you want to delete the workspace, then all you're going to do is give the name. So now we cannot delete your default because that's, as the name says, default. So just go ahead and say Terraform workspace delete, and it will go ahead and delete your state file also. Okay, but right now it says it's not empty because if you delete, there are some resources already created. So ideally what you should do, you should first switch back. Okay, and then Terraform destroy. Okay, now this is again just a generic question or maybe from your certification. So what happens, I mean, what is dangling resource? So dangling means it doesn't have any connection to anything. Because in this example, if I forcibly created this and deleted this particular test workspace and deleted the .d folder, then Terraform will not know anything about that state file at all. But still, the resources is created and it is maintained separately. So that means you don't have any contact to it. So those kind of resources which Terraform cannot manage because you have manually deleted it, then it's called as dangling resources. Okay. So now once you destroyed, okay, so if you just try to switch back, then you can delete the folder. It's actually the same way, but instead of that, you can just go ahead and say delete. Okay, so now it deletes. Now you don't have anything, but still you can just go ahead and delete this folder. Getting it? So this way, workspace helps us to switch between multiple states within the same configurations that you have. Okay. Any questions?
Both the workspaces were
But we
pointing to
can do the same. But we can do the same using different folders. Why do we need this workspace?
You can do different folders. So logically, when you're doing some development, it's always necessary that you have to track everything, right? And where are you going to store all this? So once again, once you do all the changes, you are going to store it back into your repository like Git repository. So that way, if you need a particular location in which everything is maintained, it's always easy because you have the configurations. So everything will be maintained from that. Again, logically, there's no difference. As you said, I can have multiple folders. Instead, it's always better that if you are doing parallel development, it will be difficult for users to just switch back between different folders and keep testing. Instead, you have everything in one folder. Tomorrow, I'm asking you to rerun. You need all the source. So instead of having multiple folders, you're going to put everything into one folder and check in into your Git repository. So wherever you go, you just do a Git clone and you will get the entire folder and you can start working. But if you have multiple folders, then maintenance will be a little tricky, right? So you need to maintain different folders, make sure it is all up to date. So instead of that, if everything is put into one folder, you just switch whenever you want. And anything that, okay, that's where in the Git logic we say push or pull. So whenever you modify changes and push it back to Git, it's just one command which will take everything from your current folder. So it will be a little easier to manage.
Okay, sir, got it.
Both the workspaces were pointing towards the same main.tf file.
Yeah, configurations are the same, but the values that you pass on the state file will be different. Can you just try to create a new workspace and try to change and just come back and just once again try to run and see how it works.
Yes, trying. As long as we don't do a Terraform destroy, we can't delete the newly created workspace, right? It's showing error.
Yeah, that's what I mentioned. Because if you already have a
Ending resource.
state, right, and if you delete the workspace or the state file, then what will happen? The resources are there, but you're just deleting the state, because next time Terraform will not know anything about that if you delete the state, right? So in fact, why it is not allowing you to delete workspace? Because workspace is related to the state file. So because of that, if you delete, the resources will be more referred as the dangling resources. Okay, so that's what I was just trying to show. And that's where you
Yes.
need to pretty much first remove the state file. For that, destroy, and automatically the content will go off. And then when you destroy, it will be just removing it. If not, it will be calling it as a dangling resource.
Yes. Done.
Yeah. Has everyone tried?
Yes.
Others?
2 minutes.
I'm sorry. You're trying?
Yes,
Okay.
sir, trying.
Yeah, sure. Take your time.
Yeah, done, sir.
Okay, cool. Okay, so now you're familiarized with the state. And what is the state file? How do we create or how do we generate it? And why is it important? Now let's move to another topic, which is modules. Okay. So what do you mean by a module in general? Because you might have gone through a lot of scripting or programming, right? So what is a module in general?
Maybe consist of a bunch of files belonging to the same domain or similar concept.
It may be a library.
Okay. So what's the purpose of it?
We can use those functions or the code which is available in it.
Okay. But yeah, but what's the whole point? Why do you need a module?
To store a similar concept in at the same place so that once we import it, everything gets imported along with that.
To organize
Okay. So
everything according to the
Mhm.
to
Basically,
organize
Organize.
everything.
Okay. And again, what's the purpose of organizing?
also making it reusable.
Exactly.
Re-
That's the word.
yeah.
Reusability, right? So you can reuse it again and again. And basically, it's just collection of certain content. So rather than you writing it again, you kind of reuse it. So you just point to that, and internally, whatever is there, you will be getting back everything, right? So that's what we call it as module. So in programming, so you can actually put different functions and content together as a module, and whenever you want, you just import that module so that you will get the entire functionality wherein you don't have to write your code. So the same logic is also applicable in Terraform. So now what we can do is, when you're trying to write a configuration file, by now you know that to define your configuration, you might be requiring, or to define your state, you might be requiring multiple configuration files. So you will have the main.tf in which you will be defining your providers or mainly the resource blocks. And then your backend will have your details on where do you want to store your state. You will have your variables tf, which will have your variable block. And then if you have an output variable, and then you're going to use it to store it under output.tf. So this way, if you want to reuse the same set of configurations, then that is where you can put a combination of whatever files that you want together and call it as a module. So that every time you call that, you will be getting back the entire infrastructure ready for you. So that means now I have a project for which I have defined my configuration TF files. Let's say that will create a VPC and that will create a subnet and blah, blah, whatever the configurations internally. Now, if I want to redo it again, now all I have to do is put it as a module and just call it. And while calling, you can just pass different values, right? So by passing different values, what will happen? The same set of code will be able to reuse at different places. So that is how, when you're going to develop your configuration files, it's always good to make it as a module so that you can reuse it. Okay. So basically now when you say a module in Terraform, it's all about a folder. Okay. So just like how you guys were saying, it's a combination of files and put into a single location or a folder, the same thing over here. Whereas now, whenever you say a module, it comprises of a folder inside which you will be having various configuration files. Okay. Now, when you say the various configuration file, the first file that Terraform will read and then proceed to other files is called as the main.tf. Okay. So if you are creating a module, and in that module, the very first file which Terraform will start reading, and from there it knows what are the other things it needs and what are the other TF files that you have in that folder from which it needs to read the content. And that is why so far I was trying to tell you that whenever you try to write, always try to write it as main.tf so that you get used to the logic of modules. Okay. So now what happens? In fact, so far that you are working, where you created a folder and you created a main.tf, a variable.tf, and an output.tf, right? So that is also acting as a module. The only thing is you didn't use it properly from another source. So that way, those modules or those set of files where you are trying to run directly is also called as a module, but it is referred as a root module. Okay, so that means knowingly or unknowingly, you are working on a module only. And what is that module called as? Root module. Because that is the first module that you are running, and from thereafter you can call other modules from this. But if you're not calling anything, but ideally, then it just becomes only one module by itself, which is root module. Okay, so from now onwards, what we can do, we can actually create a folder, and in that folder, what we can do is put whatever the configuration files that we need, wherein the first entry point to this module and start reading everything will be the main.tf, and supporting it, you're going to put different files with different blocks based on your need. Okay, and if you are going to call this, then you need another configuration file, and that is what we call it as the root module. So from the root module, you can invoke whatever the folder that you have, and all the files inside it will be imported during runtime. Okay. And for this, now if you go back, so this was the folder what we had for our Docker or AWS or data block. Now this is what we did. So ideally, this is what you're going to call it as a root module, because this is the one what you're getting executed. And in this, for every module, the first file where the Terraform starts reading and executes is the main.tf. And these files, what you have is supporting to this main.tf on the root module. But if you want to create, so this is where what you can do, you can create a module folder. Now it's not mandatory to create here, but you can keep it anywhere you want. So create a folder, and within this, you are going to create a separate folder where each folder is going to act as a module. So for example, if I'm creating two modules called module 1 and module 2, then what I can do, now for every module, I can have a folder within this. And for each module, I would have a main.tf and supporting. Now it's not mandatory once again that every module should have all the three files. So maybe I don't need the output, then I can just put only main.tf and variable.tf. But however, now this will be your root module from which you can call any of these child modules. Okay, and whenever you are calling the child module from the root module, it would be invoking the first file is called as main.tf, and supporting this, whatever the other configurations you need will be within this folder. So that is how during runtime you can choose which module to call, and all this will be imported to the root modules main.tf during runtime. Okay, so that is how you can completely reuse your infra. So you can set up whatever the configurations you want and recall it, so that only at that time invoke it and all these things will be getting executed. Okay, now with this basics, Now let's try to set up a simple module and see how the module architecture will be set up. For this, what we will do, we will go back to our previous example of the Docker, where what did we do in the Docker? Now this is one of the reason I always take this, because it's very simple and easy to understand. Okay, so here now we had one example in which, so you have two resource block. One is for image generation and another is for container. And then further, there are some variables which is needed for both of them. There is one variable which is a user defined variable for image, as well as for the Docker container, I need the container name, internal port and external port. So these are the things that we had. So let's do a module where we will split this itself into a root module, and we will split into a image module and a container module. That means I will create a module at any point of time when I call, it is going to just create or download an image for me. And I can have a separate module where whenever I call it, it will create a container for me. And both of them, we will invoke it from a root module. Okay, so this is what we are going to do. So just pay attention and I'll just show you. So first, what we will do, since we are going to work on the module concepts, now I'll come out of this. Okay, so what I'll say is I'll create a folder called mod. Okay, so that it's a module. Okay, now first I am going to require a root module. So for which I'll just create a dummy file, main.tf. Okay, now supporting if I need to pass any variables, I can create further. But this is considered as a root module where it has only the main.tf. Now in the same folder, what I want to do is I will be following this structure where I will create a module folder, and then I can create two modules which are two subfolders. So for that, first what I'll do, I'll create a modules folder, and inside that I will create two subfolders, that is image and container. You can give any name to your module folder. Okay, so now inside the mod, I'll just create first modules. Okay, so let's go inside modules, and here I will say mkdir. One module is called as image and the other one is called as container. Okay, so what happened? So we created two folders, which is subfolders inside your modules. So each one of them represents a module for us. Okay, now this is where inside each one of them we are going to define what is those configurations that we need. Okay, so for that, so let's start with this. So this is where I'm just saying you can go ahead and create a folder in your current directory, modules and image. Anyway, if you have done, now I will create a main.tf, and inside that I will just put Docker image, okay, and the name of the image. Okay, whereas instead of hard coding, I will pass it as a variable. Okay, so this is what will be my main.tf content. So first we'll go to the image module or the folder. Now this is blank, so let me just create a file called main.tf, and I also need variables.tf. Okay, and I also need output. Okay, so just in case, now it's up to you to choose what are the different configurations you want. So now just to show you, this is a module wherein I'm having all the files. So let me go to main.tf first. Okay, so I've just mentioned only the resource block. All right, fine. Now for this resource, I need the variable. So here what I'm going to do, so either I can hard code a default value. If not, every time when you run, it is going to ask for a value. So that way I can make default equal to, okay, so let's just say nginx. So I'll open the variable and here you give. Now, what I want to do is in my output, whatever the image that I'm generating, I just want to get the output variable where I'm capturing the image ID. That is what is the latest attribute. So here we'll just paste it. Okay, so that's what we have. So the only thing now we have to do is to quickly test, even though if you take it directly, this also acts as a root module. But if some other module is calling this, then this becomes a child module. Okay, now how do I test this? So basically you're going to do a Terraform init. Okay, and it looks like we have to run the upgrade first because it doesn't know the plugin. So let me run it. Okay, so I've just executed the Terraform upgrade. Then we'll do Terraform init. Okay, because I'm just directly testing this like how you do regularly. Okay, so Terraform is working fine. Init and then Terraform validate. Okay, it's fine. And then let's do a Terraform plan. So it should tell me there is one resources. So let me go ahead and say Terraform apply. So it creates. Okay, so now same way if I do a Terraform destroy, this will be getting destroyed. Okay, so this is what we call it as a module, but internally it's just a root module by itself. But to cross check what we're going to do, so we're going to just quickly run this. So Terraform, yeah, for the first time you just have to do the upgrade. So what's the command? Yeah, just have to run this. And then just do a Terraform init and Terraform plan and Terraform apply. Yeah, once you have done, just go ahead and delete by saying Terraform test try. Okay, so all we have done is created one folder in which whenever you run a Terraform plan and an apply, it will just try to create us a resource called as the Docker image. Okay, so this is equivalent to assume this one. There is one folder. Okay, so now this folder can be treated as a image module. So whenever you call, what you're going to get is a Docker image. Okay, so what I want you to do is try running this first and do it along with me. If not, it will be very big. So try creating this example. I'll just paste you and create a folder, and inside that create a modules folder and then create an image folder, and inside this try to create main.tf with this content, variables.tf with this content, and output.tf with this content. So anytime if you go inside and call your Terraform plan and apply, you should be seeing a image generated. Okay, so can you quickly do this now?
How many folders are there? Modules and image. Two images inside module, right?
So there is a parent folder.
Okay,
Inside
mod.
that, you're going to create modules, and inside that, whatever is the name of your module, which is a folder. This is
So
what it
this
is. This is one folder. Mhm.
this image corresponds to module 1 in this PPT, right?
Yes.
Okay.
So this is my mod folder. This is the modules folder, and this is equivalent to image folder or container folder.
Yes. Why did we do a Terraform destroy at the end?
Sorry.
Why did we do a Terraform destroy at the end?
Yeah, just do it because right now I'm just showing you as a separate folder you can access, right? But then later we will see like a particular module how to use. So that way you don't need the resource to be available because you are not going to manually go into this folder and call. So that's why just for testing, what I mean to say is just do a destroy.
So we'll be calling this image module from the mod module, right? In later.
Yes.
Okay.
Yes.
It's done.
Has everyone tried it?
Yes.
Still trying.
Yes.
Just wait for a couple of minutes.
Okay. So if everyone has done it once,
Yes.
Hello Adam,
okay.
I'm just getting one error while destroying this image. Unable to remove
What
Docker image. Error response from daemon conflict. Unable to delete.
what is your configuration you have given?
Just this. Just what you have pasted in the code. Mostly the same only. Image and then the variable and outputs. That's it.
That's just a simple one. You should be able to do it.
Hmm.
Can you share your screen?
Just wait. Yeah, so are you able to see the screen?
Yes. Have you created a container?
Yes, I've already created one container just to see.
Yeah. So that is the reason. So it's saying that there is a container running. So since there is a container running, image cannot be deleted. So you delete the container and then run the destroy, it will work. Docker PS. Yeah, running, right? So just say Docker rm
R.
space rm
Acha, remove RM. Okay.
space force hyphen force
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 hyphen force
hyphen
hyphen force
space test me.
space. Sorry.
Yeah, name of the container, test me.
Okay.
Yeah, now try this Terraform destroy.
Okay. Yes, it's done. Okay. Thank you.
Yep. Okay, so what we did is just we created a image module, and in that we just put a simple
So wait
resource
1 minute.
for image creation. Yes.
Wait 1 minute. Yes, sir, done.
Okay. All right. So again, as I was saying, this module is just to create a Docker image, and for that we splitted everything into a resource block, a variable block, and an output block. Okay. Now what we'll do, let's go ahead and create our second module, which is the container module. So for this same way, I already created it in the beginning. So just want you to create a container folder, and in that, what we will do, we will try to create a resource block where we will say what is the name it needs and what is the image name that it needs, and corresponding to it the variables. Okay, so here I'll go to the container folder. Okay, so here I don't have anything, so I'll create a main.tf and a variables.tf, and here in the main.tf I'll try to put this resource block, and for this I need 4 variables: container name, image, internal port, and external port. And if you look carefully, I am hard coding the variable name here. This is because the image resource is on a separate folder or a separate module. So that is where we will not be able to get that directly here. So instead of that, I'm passing a value to this variable. Okay, so whatever the value I pass, this folder will take it and it will execute. And for this, the container name, image name, Let me give some default value also. So what I'll do, I'll say default value for container name is just me, and same way for the image. Once again, I'll give the same whatever I have downloaded there so that you get the same. And on the internal port, I'll make it as 80, and external port, I'll also make it as 80 just to see. Okay, and this we will give it as the variables.tf. All right, and to test, I'll go through the same process. So I have to do a Terraform upgrade because only on this version. All right, and then Terraform init. In fact, you have to do a Terraform validate also, but yeah, I know this is going to work fine. And then Terraform plan. So it says one resource and Terraform apply. So it will create a container for us. Okay, because the image is already downloaded. Okay, now if it is not, it's going to give me an error now. Okay, so the image is already there. So we're just going ahead with execution and we see it's available. And when I don't need, I'm just going to say Terraform destroy. Okay, so this is what we have done. But now, if I go inside this separately, this also acts as a root module where I'll be able to get these, right? But quickly do this and try to make sure you have a separate container folder, and in that you have the variables.tf and the main.tf so that you can run it separately. Okay, and then we will try to invoke it as a child module further. So quickly, can you just go back and try these two things? Create a new container folder at the same level of the image here. And now inside this container, create main.tf, variable.tf, and then quickly run it. Okay. So try it now.
Yes. So image and container both are independent modules. They are not dependent on each other.
As of now, it's independent.
It's done.
Adam, we have not mentioned a provider block over here. So how is it able to figure out like
The upgrade, when you do, it will take it up default.
acha by default it will take okay.
Yeah. Because here there's no connection, so it should be taking it.
So it directly finds out that it's a Docker provider something.
Yeah.
So does it work for everything or just this Docker? Like suppose if we have
Only for
not
Docker.
only for Docker, okay.
Yeah.
Done, sir.
Okay. Okay, fine. So now we have two separate folders. So how do we treat it as a module? Because unless and until you don't call this from another root module, this is just going to be like a normal folder, which is what we call it as a root module. Now, if I want to call this, so I need a parent or a root module. And this is where you can see we have a folder separately called main.tf. And this is what is going to call these two. So in case if you want to call that, then what we have to do is basically, if you come back, there is a new block for that. Okay. So from a root module, if you want to call a child module, then you have to give a block called as module. And there you're going to define what is that module that you're going to call and what is the location in which available and what are the arguments that you're going to pass. Because rather than you going to that folder and executing Terraform plan or Terraform apply or destroy, you do everything to the root module and the root module will pass everything to the child modules. So that way, what is that commands that you want to pass or modules and what are those options you are going to give it here. Okay, so to define, so let's go back and see how this will look like. Okay, so first, now what we will do, we will come back to our root module. Okay, and in the root module, okay, so all we have now is main.tf. So if you edit the main.tf, now you will give a block called module and give a name. So this is just a name what you are going to give, and inside this you are going to say source name. And what is the source name? Is nothing but the folder where you have your child module. And this is where I'm trying to tell, in the current folder there is a modules folder and inside this image. Okay, and after that I have a image name, because when you're running this you can also pass your variable, because if you don't pass, there are some default variable which is hard coded, but now during runtime you can pass a variable to this. And once again I can hard code it, but instead of hard coding you can also pass a variable to your root module, and that root module will pass it to the child module. Okay, so whatever that you are seeing on the right side, these are the root modules variable. Okay, so now when I say module and the source and the image name, and for this I'm going to pass a variable, then it will go to the module called image and the folder, and inside that it is going to do a apply, and while it is applying it will pass this variable, wherein on the left side whatever you see, this is the name of the variable that the module needs, whereas here the name of the variable that you are passing to the root. So probably just for you to understand, I'll call it as root image name, and same here, root container, root init, and root external. Whereas these are the variables that you need for the module. The same way for a container module, I'm going to call and I'm going to pass these three values, which is what you are going to give. But look at this now. Now all the other things I can pass, but why should I hard code the image name again? Because when I call this module, we know that this module is going to generate an image and there is a resource. But the difference is, so far what we were doing, when both the resource block were in the same configuration file or module, we were directly able to interpolate by saying the resource name dot the attribute you were able to get. However, now the resource is on a different module or a folder, and here it is different. So this is where if you want to read a resource and its attribute from a module, it is not straightforwardly possible. And this is when you are calling a module, we have used the output variable. Okay, so if you go back to image, do you see we have captured output, and what is this? So it is going to give me the image name, whatever it is giving, and it is returning. So far, when you run it directly, where does this output variable return the value? To the console. But now, who is calling this module? We are calling it from the root. So that way, when you call the root module will get the output variable. So now, if you want to access that output variable from a module, then you are going to say the interpolation as module dot the name of the module and what is the output variable name. Okay, so this is where your output variables will be actually used. So this way, now what happens? You call one module, make sure whatever the values that you want to pass to another module, you put it as an output variable captured. And when you go to another module, you try to use it. Just like how within the same configuration, if you are accessing another resource, you were saying resource.attribute. But right now, you're trying to access a module value from another module. So that way, you're going to say module.image. The name of the output variable. Okay, getting this first, how you are calling your modules and how you are passing the variables.
It's a little difficult to understand.
Which part you didn't understand?
The calling part, module.image.image out we are using, but for import export we are using a root variable. Why is that?
Okay,
Why we are doing
wait.
so?
Did you first understand this part? Is there any question on this?
No,
Okay, fine. Now, when you call this module, what will this do?
this will go to images, image wala main.tf, and from there it will pick up the variable, right?
No, you are passing a variable, so it will get overwritten. See,
Okay.
what is this? Image name. This is
Image
nothing
name.
but a variable you are passing. So this is equivalent of saying like this, go to that folder and say Terraform plan -var image name equal to some value. So this is what you are trying to tell. Okay, but instead of you going to that folder, you are trying to ask your root to do that.
So
Getting
in the
it?
first part, we are sending the value, while for the image inside that container, we are receiving the value from the module, right?
Correct.
Okay.
Others?
So like to
Okay,
clarify just in the first module, what in the first block, you are going to give some variable into the root image name, right? Yes.
correct.
And that is being passed to the this module image module, and then
Yes.
upon that value it will download the image.
Yeah, because
Mhm.
now if I directly go to the image module, here I have hard coded the value. So in fact, if I don't give this line, what will happen? It will try to download what image? It will
Default.
try to download the image, the default. Now this is where the whole concept of module is. I can choose whatever I want. I don't want to hard code that, but it's just a default. So how do I pass it? So this is where instead of me going to that folder and calling, it's a module. So while I'm calling the module, whatever the variable name that you want, you're just going to pass it here.
Okay,
Clear?
clear. And in the second module, what you're doing is you are giving the container module this output of the image that
Same.
you are saying. Yeah.
Wait. wait. That's what. Now, when you go to the container module, I have 4 variables hard-coded. Now, instead of this, I can pass 4 values during runtime,
Yes.
right? Now, that is what I'm doing here. Forget about the values on the right side. But do you see these 4 variables?
Yeah.
And this is
Yes.
what is the variable that you see here. Okay. So that means you are calling module and you can pass whatever the values that you want. Okay. Wherein
No.
these are the name of the variables which these modules need and you are passing. If you don't pass, it will take the default. But that is what I don't want. So I'm trying to pass this. Okay.
Okay. So
Clear on
here
this
this
first?
the image module dot image dot image out and where dot
Wait,
root
wait,
image
wait.
will be same, I
Wait,
guess,
wait,
right?
wait. No, wait for a minute. So
Mm-hmm.
now when I call this, it will create a container with the values. When I call this, it will create a image. But now, if you go back to the very basic Docker example, so here, what is that we were trying to do? Now, when I have 2 resource block internally, was I hard coding it again? No, because whatever the image that you have downloaded, this is what I want to pass here, correct? Because logically, this input is what I need, right?
Yes.
Okay, now this was working because both the resources were in the same block. In the sense, not the block, the same configuration or same module, right? So that is
Right.
where when you call a module, both the resources are there. So this resource knows this resource and Terraform was able to get. But right now what is happening? Are both the resources in the same module?
Yes.
No.
Right now
This
they
we
both
have
in the different
stored
module.
into a image module folder, and this is we have stored into
Container
what? Container
module.
module. Cat modules image main.tf. What do you have? Only the resource. Cat modules container main.app. What do you have? So now both of them are separate, and the same way when you are calling this, the modules are also called separately one by one. So obviously now this resource doesn't know anything about this resource, or in fact the entire module itself doesn't know anything about this resource. Is that clear?
Yes.
Okay, then how do I get the value? Because what I want is, I don't want to hard code the value here. Instead, whatever the value that you are getting, I should be passing here. So this is where it is not directly possible. So that's when the output variable will be coming into the picture. So in that, whenever you are trying to run a module, if you try to capture a variable using the output, it will be returning the value. So that way, now, whenever you run this module, it is going to return a value, which is nothing but the name of the image or the ID, which is what we have already given here, right? In the output, getting this point?
Yes. Yes.
Okay, so now where is this getting returned? It is returned to the root module which is calling. So whenever root module calls this, it now knows that there is a variable called image underscore out. Okay, so that is what you are going to refer here, because both the modules are invoked from the same root dot module. So root dot module, if you refer as another module and the name and the output variable, whatever has been written here, it is captured in the root module and it is substituted here.
Okay, got it. So this
Getting it?
image that you mentioned in the container module dot image dot image out is going to be the same as this variable, right? Root image name, where dot
Yeah,
root
so
image
whatever that you have passed, that is what you are going to get it.
get it.
Now, here, don't compare it like a variable. Assume this was a different property. I know this is very straightforward. I can pass
Mm-hmm.
the same, but
Yes, yes, right.
logically, if it was some other property, then this is going to get that property out of the resource created.
Got it.
Okay. So this is what we are going to do. So now in the root modules main.tf, all I have to do is put these two and I have to invoke. But now for your root module to pass, you need to create a variables.tf, because these variables that you are seeing, it is part of your root module. So that is where finally what you are going to do now is create a variable.tf, okay, and put this, the values whatever that you want, okay. And once again, now I can either hard code it, or when I'm calling my root module, I can also pass my own values. So this is where everywhere, if you don't give, it will take default, okay. So now see this, so I can create, okay, see here, one small change is this root, and this is what you see above.
We had already created variables for name of container, image, a root port, external port, internal port. Why are we doing the same thing again? Why aren't we
Which
calling
one?
just the way we called it in module.image.image out? Why aren't we calling the same in the same way these variables?
Okay, now tell me, the value of this is obtained from here, okay. Now what is the container name? If I don't give the value here, what will it be taking?
The default value which we have mentioned in the container
Yeah,
module,
I
right?
don't want to give default value. No, that's what I'm saying. See, I
Okay,
don't want to give a
okay.
default
Acha,
value.
now I understood. Yeah, yeah, yeah.
Then what should I do? Because assume you are creating one module which will create a machine, and you are hard coding saying that the AMI will be CentOS or Ubuntu. Every time I call a module, will it be creating only CentOS? Rather, keep a module in such a way that the user should give the AMI ID and it should be creating. The rest of the thing should be there. So this is where now, rather than hard coding, I'm going to create it as a variable, because this is what we learned. So what is the necessity of a variable? Either you set it as default, or you have a option to pass it during runtime. So during runtime, if I don't pass anything, it will take it as default. For example, the container name is Vesva and it will be running. But if I want, I can change this to Vesva Tech and run, and it will be taking that. So that way you have the complete flexibility of changing everything. But at every level, you are going to set up some default values, so that if it is not given, it should take certain default values.
Yes, yes, yes,
Getting it?
yes.
Okay. So now if we go inside, so this is our root module where I'm going to call these two modules. So that way here, all you have to do now is, since it's the beginning, so just go ahead and say Terraform init. But since it's a Docker module, if it asks you to do the upgrade, then you have to do it from here. Okay, now anyway, you have done it inside. So from here, if you do, it's okay. If not, first you have to do that 13 upgrade first and then do init. Okay, because we did everything individually, it's already there. So now, whatever that you want to communicate, you do it from here, so that if I say Terraform plan, what will happen? So you're doing it on the root module. And before that, validate. So it is going to all the modules and it will check and everything is fine. And when I say Terraform plan, now you can see it is not directly calling, but module container, and in this is the container resource, image module and the image resource. Okay, and if I say apply, then it will be creating everything accordingly. Now anyway, I have a variable, so I can pass different values based on my need. So for that, if I just say plan hyphen where and whatever the variable name I want. Okay, so I can pass this also. So what it will do, so right now, just to show you, it's taking whatever you have hard coded in the root variable. Now if I pass, instead of that, it will overwrite. So this is how you can go ahead and kind of manage your root module, and that will be handling your child modules. Okay. And internally, it's been calling. And same thing when I say Terraform destroy, what it will do. It will go back and destroy from both of the modules. Okay. So this is how we are going to do everything together. Okay. So try with this also. Now create your root module, and in the root module, now create main.tf and variables.tf and put this content, and then pretty much try executing the workflow fully. So this is what we are just talking over here. So your root module, your image module, and container module. Clear? Can you just quickly try?
Yes.
Let's try.
Yep.
Hello.
Yep.
So the advantage was we didn't have to create resources in the root. We only provided with values and variable name, and the resources got created, which we had mentioned inside the sub modules, so child
Correct.
modules.
Yeah, so you completely have the comfort where you can leave it by default, or when I'm calling this, as I said, I can just pass this, right? And I can apply so that I can pass my runtime variables to the root module, and the root module will further pass it to the child modules.
Yes.
Got it?
And the output we mentioned inside first image module was is because even container wanted that image name. That's why we had to return it to the container. That's why we mentioned about output, right?
Yes, because only when you have resources within the same module or configuration file, they will be able to know. But since you put it as separate folder and separately you're going to run Terraform plan and apply, by default it will not do. So that is where by using the module and the output variable, we are first returning some variable of our choice from first module and capture that and pass it to the second module. And these will happen in the root module. So that is where root module knows about first module and second module, right? And that's where you are just using the module or the interpolation module dot something on the root module.
Yes.
Others, has everyone tried it?
Yes, sir.
Are done.
Everyone?
Yes.
Yes, sir, complete.
Yes, yes, it's done.
Okay, cool. So now clear with modules, right?
Yes, it's clear.
Okay, fine. So take a break. We'll continue post lunch. So it's 1:45. We'll meet back by 2:30.
Yes, sir.
Yes.
Okay. Hey guys, is everyone back?
Yes.
Yes.
Okay, what about remaining?
Yes, I'm back.
Okay, it's like Terminator's dialogue. I'm back. Anyone else is back? Okay, you still don't hear from others. Humira, Kajal, Rahul, Shraddha, was that Sri Shail?
Yes, Sri is back, sir.
Okay, Surabhi, I didn't hear you. Are you there? Okay, all right. Did you guys get a chance to go through those examples, or is there anyone still trying to run the module example?
It's done work for me.
Done, sir.
Done.
Okay, anyone still trying, or can we move to the next topic? Okay, so let's move ahead. So on the older versions of Terraform, again, the syntax used to be a little different. And on version after 12, there are some built-in functions which has been added on top of existing functionality. Okay. So this is where on Terraform 12 or greater, you will be able to use all the different types of built-in functions which is available. Pretty much when you start writing your configuration file, you will be able to see some keywords which will help you to kind of return some values. Okay. So just like any other programming language, now these are the functions which is built in within Terraform to help you to do some kind of not exactly arithmetic operation, but certain operations can be done on top of some values within your resource block. Okay. So you cannot create your own functions because again, it's not a programming language, but these are the ones which comes by default, which you can use it. So in that way, there are plenty of functions, but let's go through a couple of them which we'll be using. So when you're invoking a function, now you have to pass some argument to that. And this function will be returning a value depending on what is the functionality. Okay. So obviously what will happen now is when you're trying to write your configuration file within a resource block, wherever it is needed, instead of the value for a key, you can substitute this. So what will happen? Instead of directly hard coding some value, you might have to process some values or run some function and get that output, whatever you're returning from this function, as the value to that key. Okay, so typically instead of saying key equal to some value, you can just kind of put this function which will be returning the value coming from this function. Okay, so remember, wherever you see a keyword and in the parenthesis some arguments, then it means it's a built-in function in Terraform. Now there are few that we know, but now for us to run this, now pretty much you have to execute a playbook, sorry, you have your Terraform configuration files and run. But this is where, like Perl or Python, you can try to run something called as a Terraform console, where you don't have to execute your complete configurations, but instead you can execute some of the function and try to do some basic debugging for some expressions. Okay, so this way, if you enter the command called Terraform console, so it will be opening up a console where it will be an interactive way of running. Now here, just to show you, so if I just say Terraform console, okay, so you can see it goes into a user input mode in the console, so that now you can try to run these functions, and in case in the previous output variable, whatever that you have executed, right, you will be able to get, whatever that you type will be now taking it as a function. So what you can do is basically try to play around. This is where you can use all those built-in functions and see how it is going to work. Now let's see a few examples. Now assume I have some multiple values, and if I want to find out the greatest of this, then there is a function called max, and if you pass, the return value of this will be the maximum number out of what you have given. Okay, so here, this is where the console will be easy for these kind of things. When you enter, you can see it's simply going to just return the value what you have got here. Okay. Now it can take as many values that you pass. Same way, for certain scenarios, if you want to convert some string to an uppercase, then there is a function called upper, where the argument will be the string that you want to convert into uppercase. So now if you just execute, you can see the return value of this will be uppercase letters of the same string. Now, given a string, if you want to split, like how in Linux you use the awk command or the cut command, where you can split a string into different strings. So now, given a string, and the first parameter will be the delimiter, based on which the string has to be splitted. So here, if you see, so we are trying to tell that this is the string, and in this, divide it or split it using a delimiter called a. So that way, here it is going to split it into Tom and 2. Okay. But however, when it is returning, you should see that it is returning two values. So because of this, the return value of this split function is basically a list or an array. Okay, where you are trying to have two values. So this is where, suppose if you are assigning this to a key or a keyword, and if you want to capture the value specifically on the first one, then you have to say the whole function and in the square bracket of 0, and this will be returning the first index. And if you want the second value, index of 1. But however, when you try to capture the whole value, this will be storing it as a entire list. Okay, so that is where again your variables is important. So depending on whatever the delimiter that you give, it will be splitting everything. Suppose if I just say 0, you can see, so there is 1 here, which is the first one, and there is second one, and after this there is nothing, so that's where it's kind of giving you a space. Okay, so it just splits the string with a given delimiter. Now, upstring is a function where, given a string, you can cut of a desired length. It is not going to split it, but it is just going to cut a desired substring from it. Now for that, you give the string and the starting index for your substring which you want to cut, and the final value or the index to which it has to stop. So if I say 1, 4, then it will start taking from 0 first index and second, third, fourth. So it will just give this output which is ELLO. Okay, so you can change the starting index and the end index of your substring, which it will try to cut and give it to you. Okay, you can see. Now I can just change this. So it kind of gives you. So typically from a given string, if you want to just kind of parse through them and cut only a list or a sequence of characters that you want, then you can typically use substring. Okay. Now there's another one that is index. Now what is index here? Okay. Now index means in a given list or an array, if you give a value, it will be returning you the index number of the value. Because so far what we know is, if I give a array or a list and give the index number, it will return the value. So this is the opposite of it. So if you say index and give the array and the value, it will exactly return you what is the index number of this. So in this example, if you try to run, the index number of B is 1. So if I say C, it will be 2. Okay, that's 0, 1, 2. Okay, so if there is a need, then you are going to use index to return the index number of a value. Now, length. So again, it's like your program. Given a string, if you want to count the number of characters, then if you say length, it will return you the number of characters for a single string. Okay, you can see if I give this, it gives me 6 because it's counting everything from this string. But the same, if you give an array, then length will return you the number of elements or index in this. Okay, you can see it gives me 2. That is because there are 2 values in it. So go ahead and just say C, you give 3. So that way, remember, if a string is given to length, it will return the number of characters. But if you give a list, then it will return you the number of elements or number of values in that array or list. Then lookup. So this is quite useful when you are using a map. So suppose, assume that there is a map variable. So let's say in this example, so I'm trying to say that there is a key called A and there is a key called B and its corresponding value is AABB. So the first one is the value, which is the map. Second one is a key name. So what does it mean? Suppose if in this particular map, if there is a key available by the name A, it will return the value. Okay, but what if the key is not available? Then whatever you give here will be returned as the value. Okay, so watch this. So there's a key and because of that it's returning, let's say B, it returns BB. But if I put something else, then whatever the value that you have given, that will be there. So you can just go ahead and give your value of interest. So in this way, if the key is found, you will be able to get the value. If not, you can set some default value using this lookup function. Okay, there are pretty much few more, but as we go through, we will see. But quickly, can you just try this once and see how this is working? Just type Terraform console and just go ahead and give these.
Yes.
Okay, and once you have done, just do an exit, you will come out. can you quickly try and see how it is working? See how it is splitting and what kind of value that is returning.
Hello.
Yes.
What if I want to store the max value of 131.12 or the substring obtained from or the split list obtained after performing that function into some variable? How can I do that? Here it's showing
That's
error
what
if
we
I'm
will do.
defining anywhere.
Where did you
Okay,
define?
in the console only.
No, console is just meant for you to run that and see. But obviously, when you try to write your configuration, you will do that.
Okay, so the way we
We'll do
used
it
to
as a
define
static.
variable. Okay, okay,
Yes,
okay.
we'll do that.
Then
Okay. Others?
Done, sir.
Done.
Okay.
Done, sir.
Hey, that's cool. Okay. So now we will see how these functions are used. Okay. And as we know, Terraform, it's mainly that you define a block like a resource block, and within that, you try to achieve some state, whether you want to create or add or modify or delete something. Okay. But now, when you go back to basic functionality, now there will be sometimes you want the resource to be executed again and again, right? Or in general, what do you mean by loop? What is a loop?
Iterations. Iterations
Yeah,
to perform the operation for a definite iterations.
yeah. Just executing something again and again over a period of time. That is what we call it as loop. So what is that we have to do with Terraform and loops? So, so let's assume that we'll take an example. Okay. Now to take this example, what we will do, I want to create a user. Okay. So in AWS, how do we create a user? So we're going to simply write a new resource block called IAM user and the name of the user. Okay. Now, this is the provider block, and I'm just giving a new resource called AWS IAM user. So let me just create a loop folder. Okay. And okay, so let me just say Terraform init, Terraform plan. So you see that it says that it is going to create a user called Adam. Now, if I say Terraform apply, so it's going to create. Okay. So now it says it has created. So now let's go back to, okay, is that, and go to our console, and here, let's go to IAM. So where's our IAM here? So here you can see there is a user created. Okay, now this is fine where I create one user. Okay, now what if I want to do the same thing where I want to create multiple users? Okay, or I want to destroy multiple users. Then what does that have to do? Now, ideally, one way of doing it is I can write multiple resource blocks, but that is not a good solution because too many resources is actually going to cause performance issue at one level. So that is where, how is that I can make sure that the same resource has been reused? Because if you look carefully, what is the difference in which I want to create multiple users? So it is going to be the same block. The only thing it will be changing is the value here, right? So this way, all we need now is to make sure the same resource block is getting executed multiple times depending on how many values that I give, and that many times it should be running because that many resources it is going to create. So that is what we call it as loop. Okay. So how do you perform this loop? So to perform this loop, there are different methods that we can achieve. Okay, but let's go with one of the standard and then move ahead. Okay, so basically, first, what we have to do is there is a special parameter called count, which will tell how many times your resource block has to be repeated. Because by default, any resource block that you take, it has a built-in parameter called count, and that will always be set to 1. And that is where the resource is getting created only once. Okay. Now, if you change the value of the parameters, that is the count parameters value, that many times it will be getting executed. Okay, so now if I make this as 2, then this resource will get executed 2 times. So see what happens now. Okay, so let's edit the main.tf and I'll just add it here. Okay, so Terraform validate, Okay, it says it's fine. And then let's say Terraform plan. What happens? So it says it is going to create two resources. Okay, because the same resource has been executed 2 times. So depending on your count variable or the count parameters value, the same resource block will be executed multiple times, because by default the value of count parameter will be 1. That is why it is always getting executed once. If I say 3, you should see that it's going to try creating 3 resources. Okay, is that clear? First, how many count parameters you give, or what is the value of the count parameter, that many iterations the same loop will go through, or the same resources will get executed. Is that clear? First,
Yes, sir.
Yes, yes.
okay, and since it is the same resource block, for every iteration it is trying to track using a index number, because it is also going through the loop. So you can see for the first iteration, the iteration index is 0, and then the iteration index is 1, and then 2. So that way it is 3. Okay. Now this is fine, but if I try to apply, we will get an error. Guess why?
Same users.
Exactly. Even though I am telling this to run 3 times, but have you noted? For every iteration, it is trying to give the same name, correct? So logically, this is not correct. So what we should do now, here, I have to pass different values for different iteration. But how is that I can pass different values? Because whatever that you give here, it's going to take only that as an hard coded. So this is where count is separate, but giving values is separate. So for this, what we should be doing is, now we can pass certain variables and try to pick it up. Okay, now in this case, now I can create a variable. Okay, so let's do this. So let's create a variable. Now instead of hard coding like this, okay, now what we will do, we will take example in which I'll take the same provider and I'll create a variable called username. Now give me some names. Give me some name. Hello.
Yeah, I'm not getting any name. You can write our names only, na? Shri, John,
Give me your,
Sanil.
okay.
Sorry, not John. Shri, Sanil. All are
Shall,
there.
okay.
Rahul,
Give me another name. Rahul. Then
Sanil,
how do you spell it?
Sanel, I guess. Yeah,
Sanal.
Sanel.
Okay. Okay. Give me one more name.
Nitish, Nitish.
Okay. Fine. So
Okay.
basically, assume I want to create. Okay. No partiality. Give me a girl's name also. It's all guys' names.
Ajul Surbi.
Okay. Fine. So I'm going to just create this file. Now, this is the variable that I have to pass. But once again, when you are having this resource, how will you replace this with the values here one by one? Okay. Now that is where I cannot just go ahead and put a value, because again, it will be hard coded. So for every iteration, we should automatically take these values one by one. Okay, so that is what I want. And how do I know that I have to complete it exactly at fifth value? So this is where I cannot hard code the count here. Okay, so basically for me now, how many times this should be executed? This should be executed 5 times because I have 5 values, right? So the iteration should always happen with respect to the values. So how do you achieve this? And this is
Of
where
default.
we can go back with your functions. Okay, so in the count, if I put the length, so we just now saw there is a function called length. What will length do? We
Number
just
of
now saw that,
elements
right?
inside the
The
string.
length of the string.
Return the number of values from an array, right? So now here, if I say this, now if I want to get the values returned from this variable, I have to say var.usernames. And here I'm saying the function called length. So what will length do now? Length will be returning the number of values that you have in this variable, whatever that you have given as a parameter or argument. So what will be the value returned here? 5. So automatically now what is the value of count? 5, because you have given 5 variables. So anything that you change here as 6, this will automatically become 6 here. Okay, so you're not doing any hard code here. So it depends on what variables you pass, the number of values in the variable, I can use the length function. Okay, so this is where we are using the function. Okay, now still my name should be changed. That is because every time it is Adam. Instead, I want to take these values one by one. And that is where what we can do is use the same variable, wherein there is another small difference here is when we say var.username, it will give me this value. Out of this, if I say in the square bracket the index number, then it is going to return exactly these values. But how will I change that index? And that's where you have this property or the parameter called count.index. So when you say count.index, automatically it will be incrementing the index value right from 0, and it goes through the maximum of 4 in this case. So the index of 0 will return this, then 1, 2, 3, 4. Okay, so that's how you can iterate, for which you are going to use a combination of count parameter, which will take the length of your list so that it knows how many values are there and that many times this resource block has to be executed. And to substitute the value, we are going to take these one by one. Okay, so let's try the same now. So Terraform validate, Terraform plan. So you should see that it's going to create 5 variables, and each time the 5 resources getting executed, the value of the resource block will be changing. Okay, and now if I just go ahead and apply, so it says it has created. Okay, okay, now let's go here and just quickly refresh. You should see that same values are available. And exactly to creation, if I go back and say destroy, then it will loop through the same resource block, and with the different values, it will go ahead and delete. Okay, fine. Getting it?
Yes.
So this is how you can achieve loop in one of the way. Okay.
So these
Now,
users basically be having the same access as the user one.
sorry, come again.
All these 5 users will be having the same access as the user one. Like if
That we
I want,
haven't set anything. Yeah, that is separate because in AWS, creating IAM is separate and giving access is separate. Yes, right now we don't have any policies attached. So whatever is the default policy as a root, everyone will be getting a particular policy by default. So all of them will be same. So later on, we have to apply. Okay.
okay.
Now, here, in case if you want to capture a particular output, and this is where now you can see everything is coming as an index number. So you're going to use specifically that. So here, so what I want to do, so let's say I'll add another user. Okay, so it will try to create 6 users. Now out of this, I know that Adam user is on the first one. So I want to gather his unique ID. So in that way, when you run this, the resource block will be getting executed and there will be multiple resource. And in that, you will be having a unique ID attribute. Now I want that to be obtained only from the first value, which is the 0th index. So that way you will also be able to capture or refer to the particular iteration. Terraform validate, plan, 6 values and apply. Okay, so it creates and you can see this is the unique ID for that user. Okay, so you can just try to get the details, and that is what I'm pretty much using it here. Same if I say Terraform show, you should get the entire details. Okay, so out of this, this is the first resource block in which it has generated a unique ID. So to obtain this, we are saying AWS IAM user dot the resource block name and the index 0 so that it returns this. Getting it? How do we access that particular resource when you're in an iteration? Clear on this part?
Yes.
Okay. Let me quickly try to run this and see how the count works.
I am facing one error in the mod directory. I did something, I guess. The error is regarding error locking state. Do you know how do I fix this?
Can you share your screen? What did you do?
Yeah, sure. I received this request on my mobile. Can you send it to the other name?
There's only one. Okay.
Had opened Terraform console, and then I wasn't able to exit, so I did a Control Z. So I guess that's from that point the error has started. If I'm making a new directory now for loop, it will surely work, but I wanted to know how do I fix this error.
No, that is a console lock, I understand, but what did you run before this? I just wanted to know. So,
From here the
uh,
error started.
now before that, what did you do? Something. Okay, do you have a state file there, ls? Looks like you've been executing something, ls. Okay, can you just do Terraform space force hyphen unlock? Unlock. Yeah, the last option you can see, unlock. Enter. Lock ID argument. So what is that lock ID? Just say dot space dot. Yeah, I can give that also.
Not
Have you
working.
opened? Now, have you opened this from some other console, or is it someone else using the same machine?
No, no, no. If I'm creating a new directory for loop, it will work, right?
It
Shall I
should
check
work, but
that?
the only thing is the same folder that you're trying to do, right? So that is where I
Because
believe.
when I'm using Terraform plan, I'm not able to perform that action. Although when I'm using Terraform plan
No, see, looks like
log
there
equal
is.
to false, then it's working. Approve is also working and destroy is also working. If I'm adding this argument, log equal.
Yeah, this is what I'm trying to tell. Looks like there is a previous execution which is not completed successfully. So because of that, what is happening? There is a lock that has been put on a state. So by default, someone else should not modify. So that is what I was asking you. Have you opened this console somewhere else, same folder, and something is kind of stuck in between? That is
No,
the
the
issue.
problem started when I had opened Terraform console on this terminal, and instead of typing exit and getting out of it, I did a Control Z, which is a keyboard interrupt. Maybe that's from that point the error
Okay,
started.
can you just remove the state file,
Yeah.
both the files, and just try now?
Yes, it's working now.
Yeah, so if there's any previous execution, right, it's not complete, it kind of runs there. Okay,
Okay, so thank you.
okay. Yeah, others, just try it once.
Done.
Done, sir.
Okay,
Done, sir.
others?
Done, sir.
Okay, so this is the first method where we try to use the count parameter and we kind of looped, right? So there are other methods also to loop or iterate. because sometimes using a count parameter might not be the right one, because you might need count parameter for certain other things also. Okay, so in that way, how do you use it for looping will not be a right solution. Okay, so here what we can now do is we can use another expression called for each. So using this, you can loop over a map, or you can also loop through a particular array. Okay, so here, now the same example, what we will do is, so I'm going to do, okay, so the syntax for your for each will be for each equal to the list of values that you want to keep. Okay, so in that way, the first thing that you're going to do is whatever the values that you're passing, so you need to first convert into a set of values. So that is what, again, a special function here called toSet will work. So if you give a list of variables, it will be aligning it as a proper set, and one by one, it will be passing it to this for each. And for each, as it says, for each of the value that is obtained here, the iteration will automatically go through. So now I don't have to kind of, give the count and then the length of it, and then the index should be there. Instead, if you just say for each and give the values and converting it as a set, then you can just iterate it. Now in that, what is the name that you want to take? So this is where, instead of taking up again the index, so you can simply go ahead and say each dot value. So this is a special variable which is associated to for each, where it will be returning you each of the value that it is considering for the iteration. Okay, so the same call, what we can do now is go back, and instead of this, what I'll do, and just say for each, so that the same 6 values will be looped, but if the difference is, instead of taking the count, it's going to use the for each. So Terraform validate, so you can see it's the same 6, and you have those different values, and then you go ahead and say Terraform apply. You can see all the 6 values has been created. The same if I say destroy, go ahead. Okay, so try this once and see the difference.
Hello.
Okay, has everyone tried it once?
Yes, sir.
It's
Okay.
So it
working.
is showing invalid index in output section.
Yeah, it is showing invalid index in output. If we remove that block,
Yeah.
it's working, but it's
Which block
if
did
Yeah.
you
we are
give? Which block?
output block.
Output
We had
block.
mentioned an output block in the previous example. It's showing an
Yes.
error in the same block. Invalid attributes.
Invalid attributes. Which one did you try? This one? Here?
Yes,
Is this what you tried?
yes,
Okay. So here, now, this is because if you see, when we were using the count, what was it giving here? It was giving more as a list or an array. And that is where here it was having index number instead of this. And that is where when you gave this, it is taking it as a index. But when you use for each, when you say set, set is again something as a map. Okay. So internally now if you see the each iteration, it has been marking as this. So whenever you see there is a key instead of the index number, then what is it represented as? It is a map, right? So what you have to do now is instead of using this as the index number, here give the key name, okay? And then see you will get it because see exactly what is it giving. So if you use this, then you will get the corresponding value. Getting the difference?
yes,
Yeah, so that's the difference because earlier when we used count, it was trying to give it more as index. So that is where here also you gave because, okay, I'm not sure if the previous output is still there. Yeah, it's not there. But anyway, now if you go back to the previous example and see, the output have been given here as 0, 1, and those indexes will change. Whereas now it is more referred as a map or as a key. So that's where here it is referring as key, then exactly you should also give it as a key. So just try to change this and you should be able to run. Got it?
yes.
Okay. Okay. Has everyone tried that?
Yes, it's working now.
Okay. Yeah, that's the difference. Okay. So there is another type of iteration which we call it as for loop. Okay. Now here, I'm just going to take an example in which what happens within a particular execution of your block, you want to iterate through some values. Okay. So it is not that you're doing an entire iteration of a resource. So the entire iteration for a resource, you will use count or for each. But if I give you a value, only for that value, if you want to do an iteration, then you're going to use for. Okay. So whenever there is a single value against which you have to iterate a couple of actions that you want to do, then for those kind of scenarios, you might be thinking of using for. Okay. So to give you a simple example, now when we have some variables like this, okay, now I'm not doing any iteration for my resource, but here for each value that I take here, I want to just print it into an uppercase. Okay. Now what will happen here is for each value that I take, what I can do, I can go through iteration and convert all these values into uppercase, and then I can pass that as a value. Okay, because now when I say upper names, which is an output variable, what is that I want to take? So basically I'm trying to get each and every value that is being coming from this, and I'm kind of converting it into uppercase and then passing it back as an output variable. Okay, so watch this. Okay. Okay, for those names, I didn't give me some name now. Last time I just stopped with few names. Whom did I miss last time? Yeah, someone said Surbi. Okay. Yeah, any other name? Give me one more name.
Shubham, you can write Shubham.
Okay, fine. Let's run this. Okay, so Terraform plant. Okay, so you can see automatically it does the uppercase. And let's just go ahead and apply. Okay, so this is where within a value, if you want to go through certain iteration, right? Then on that scenarios, you just think through of using the for loop, wherein the same can be reiterated again and again. But whenever you have your entire resource block to be repeated in an iteration or loop, then go ahead and use the for each or try with using count. Okay. Now, when not to use count, we will see the next topic in which you will try to understand, because count has another, functionality. Okay, before we go that, just try this example quickly. You tried it?
Yes, it worked.
Yes.
Yes, sir.
Okay. So now just to give another example. Now using the for, we kind of iterated through a list or an array, right? Now sometimes you might also be required to iterate through a map, okay? And when you do the iteration over the map, then you can try to get back both the values of key and its corresponding value that is being mapped, okay? So to understand, let's just see this example. So I'm trying to define a map variable. Okay. Now in this, I'm trying to say that there are two keys. So one, the name of the key is Adam and the value is mentor. And then there is a key called Superman and the value is hero. So now, similar to this, when I go through the for loop, so what we are trying to do, so we are trying to say the value that whatever that you're iterating will be set in this variable. But over here, since we are going to take a key and its corresponding pair of value, so you can give two variables so that when I say for these two variables, so this is your user defined variable and in and the variable dot names, so whatever that I'm giving here, so what will happen, it will go through line by line, and for each of the line the value that you get here will be stored in name and the value that you get here will be stored in role. That is, the key will be given as name and the value will be specified as role, and that is what finally I'm printing on what exactly I want to do. Okay, so anything like how we converted into upper, so here I am saying just print, so wherein it will clearly print that this is the role what you have to give. Okay, so basically here, okay, so let's try to take it up and we'll just modify. Okay, and I have this, and let's just go ahead and say Terraform plan and Terraform apply. So you can see it just prints it. Okay, so this is how, in case if you want to use your for loop to go through a map, so then you can prefer with two variables here. The first one will take the key and the second one will take the value. Okay, just quickly try this also once. Change the values, whatever that you feel, and just try to run and see the difference. Hey, those who have done, if you guys need a break, just take a short break and come back.
Okay.
Yeah, try to be back by 4:15. Yeah, for others who want to just practice in meantime, just go back and try running these examples once. Hey, is everyone back?
Yes, sir.
Yes, sir.
Yes, yes, Adam back.
Chai, pani, coffee,
Yes,
kitty,
sir.
everything is over. So, you guys are from which place exactly?
Mumbai.
Others?
Mumbai, sir.
Mumbai.
Is it the companies in Mumbai or you guys are from Mumbai? Or both?
We are from Mumbai. Company is also in Mumbai. You're from Mumbai too?
Me? No, I'm from Bangalore.
Oh,
So how's the situation there?
cases are rising as of now since the past month. But side by side, even vaccination is going on.
I don't see any vaccinations effect. And we don't know whether it's original or duplicate by the time it circulates in the market,
Yes,
honestly. And after, if you look at our, big guys, all the pictures they post, it seems to be more fake. No one is trying to take, with all
yes.
these things, literally, it's better to be at home. Yeah, looks like 2022 will also be the same.
Please don't say that.
It's kind of, yeah, but good for you guys. You're starting your career where you're enjoying at home.
We have ended our engineering from home. We are starting our job from home. Everything is going from home.
Yeah, it's different. Yeah, you'll miss a lot. I mean, things will be good if you're at home, but yeah, but the nature, you won't feel other things. Even like, you won't feel like wearing a good dress sitting at home throughout the year. So at least for that, you have to step out once in a while.
Yes.
Yeah. Anyway, hope things will be good. Okay, is everyone back?
Yes.
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 Okay, fine. So let's continue where we left. So before the break, we were just trying to see how in Terraform you can do a loop, which is given a resource or a value, how is that you can iterate it against multiple values. But the same way, we can also put conditions, okay? Because right now, if you give a resource block, so what is happening? Terraform will consider it by default, and if it is not there, it will go ahead and create. Or basically, it considers each and every resource which is available in your configuration file, right? Now, what happens due to certain requirements, if you want to change the behavior of Terraform in such a way, based on a condition, it should be picking up. That means during runtime, you can specify certain values, and based on that, only if you tell a condition, and if the condition is returning true, Terraform should be going ahead and picking up the resource. If the condition is not matching, then typically the resource should not be picked up at all. Okay, so such a kind of things can be done in Terraform so that you can plan and decide when to choose a particular resource to be executed or not to be executed, or Terraform should be skipping that. Okay, now how do you achieve? So this is where you can put conditions. Okay, so you can also have if statement, if else statement, but it's not very straightforward, where you will be adding some blocks like if block. okay, or there is nothing called as if else block. But what we can do in Terraform is we can use the same count parameter. Okay, so what did I tell you? By default, every resource block will have a count parameter with the default value of 1. So that is where it is getting executed. So now all you have to do is, if you make the value of your count parameter as 0, then it's the opposite. So don't even run it once, or basically skip it. So this way, what we can do, you can ensure to set the value of your count parameter to be greater than 1 or greater than 1, then it will execute it that many times, or it will execute. But if you do not want a particular resource block to be considered and to be skipped, then go ahead and set the value of the count parameter to be 0. So wherein you can directly set it as 0, or you can set it through some conditions, or even pass it as a variable during runtime, right? So these are the different options that we know. Okay, so let's just see. Now this is what typically we call it as a if statement. So how do we achieve? Now let's go back, okay, to the same, whatever the count examples we had. So I'll take this old example back, the very first one. Okay, so here I'm taking this, and let's go to the main.tier. Okay, so now count is 2. So obviously it is expected that when I run Terraform plan, okay, there's 2 entries. Okay, you can see it says there is 2 resources to be executed. And this is where you can see the index number. All right, now let me open this, and okay, let me make this as 0. Now just to change and show you this, I'll try to copy this. Okay, and so I'll make this as just a difference. So now what will happen? Okay, it can't be the same. Example 2. Okay, it doesn't take numbers here. Okay, I'll just take examples. Okay.
Maybe you should put an underscore, Adam underscore.
Yeah, so sometimes it might not take. Let me just put 2 M's. Terraform validate. Okay. Terraform plan. Fine. So now you can see how many resources it is trying to tell. So it's basically running only one resource because it's considering only the first block, whereas the previous block it's trying to say it is not considering. It's basically skipping it. Okay. So I can just change this and show you once again. So I'll make this as 1 and we'll make this as 0. So now here you can see that's 2M was the second one. Whereas once again, it should be taking only 1 and this is the first one. Okay. So if I change both to 1, so this is the default. So what will happen? Now you should see 2 blocks or both the resources is going to be considered. So this is where you can achieve the condition. Okay, so primarily if you make sure that you have the value of your count parameter set to 1 or greater, then it will try to execute it. But if it is set to 0, then you will be skipping that, or basically Terraform will be skipping from execution. All right. Now, here we can use a combination of this and a ternary operator. Okay. So again, it's all basics. So if you look into this example, okay. So what I'm trying to do here, I'm just trying to create a variable called enable user creation, and then I'm trying to set this as the condition. So basically, if you go back to any scripting, if we just say if and a variable, what will happen? If the variable is defined, it will be returning it as true. If the variable is not defined, it is going to return it as false, right? The same way, anything that you put as a positive value which is greater than 0 is considered as a true condition, and 0 will be considered as a false. Similar to that, now here you pass a value and this will be considered as the condition, and if this is enabled, then if the condition is true, then the first value will be written. Suppose if this condition is false, then it will be returning a 0. So that way you can set up based on a condition. So if this condition is working, right now I'm just giving you, just to show you an example where you're just passing some variable. If this variable is available and if it is returning a true value, then the value of count will be set as 1. If the same thing, if you do not pass, then if this condition is failing, the value of count will be 0, and that means this condition will not work and the count parameter will be set as 0. So the resource block will be skipped. Okay, so just see how do we do that. Okay, and okay, and now to execute, all I can do is while calling my Terraform, I can just pass this value accordingly. Okay, so now if I set this value of this is 1, then the condition is true, then it will return 1. If I set this as 0, then the condition here will be 0, because when you say if 0, then its condition is false. So because of false, it will also set the value as 0 and this will be skipped. Okay, so you can see that now. Okay, so let's do the plan now. You can see the condition is true, and because of that, it's returning the first value, which is true. Whereas if the condition is failing, it will return the second value, and if this is 0, count is 0, and the resource block will be skipped. So you can see there's nothing, because whatever you try to run, it's kind of skipping it. Okay. So this is where you can think of deciding whether to run your resource or to pick the resource for the execution of Terraform plan or not. Okay. So just try this once before we go to another example and see how it is working. So just change the count parameters directly and see how it is working. Can you try it?
Yes.
Yeah.
Hello, Adam.
Yes.
So here, for the enable user creation variable, we can enter any value, right? Like 2, 3, 4, anything else also, right?
Yeah, try that.
So in that, case, what will happen mostly?
What is happening? So it says that whatever that you have passed should be only a Boolean value. Okay.
Okay, as per the
Because
conditions.
yeah, the variable we have not told any type, and by default here it will always try to take it as a
Consider the
Boolean
Boolean
one.
type. Okay.
So only 0 and 1s allowed.
Sir, done.
Okay, others?
Done, sir.
Done.
Okay, everybody has done it? Anyone still trying? All right. So, so what we saw here is, one second. Just okay. So here we saw a condition where if we set the count equal to 0, it will work. So it's more like a if condition or a if clause. Now, in any scripting or programming, we can also give if else, right? So the same way you can also achieve, but again, it's not very straightforward as we see. So it's a combination of the same functions what we use. Okay. Now, before we go to that, let me take another example where now when you create a user, so you will be setting up a policy, right? So for an IAM user, you will be applying a policy. So what I want to do now is take an example in which I want to create a user, and for that user, depending on a condition, apply a particular policy and apply a different policy if the condition doesn't match. So that is how we will try to do if else. Okay. Now for this, what we will do first, let's take this example. So here there is a resource block where we are going to create a IAM policy. Okay. Now for creating the policy, I need to first have a policy which is in a JSON format. Okay. Now, when I say a policy in AWS, okay, before I go with this, so did you guys go through this? What do we mean by a policy in IAM? And you're aware of what these options are? Hello?
So we do know about the policies, but not about these options. Describe it at least.
Okay. So,
We had created an IAM user last week where we had provided access only for the S3 service, and that was the only example we had related to IAM.
okay, no problem. I'll just explain you what is that. So let me just quickly create a user. Okay. And so when you create a user, you do apply by choosing certain policy. I have not applied anything. But however, for every user that you create, so basically if you go, okay, Now, I don't have anything added to this guy. So probably, okay. I can add certain policies to this. Now, if not, what we will do, I'll just show you this and I'll come back. Okay, so when you're trying to create a user, there are some policies which are already defined, which you will be choosing when you're adding the user. Okay, so when you say user and then we go, so here you can choose an existing list of policies. Okay, so here you would have used some policy saying whether he wants to have an access to only S3 bucket, or he needs to access to only machines, or he wants to access CloudWatch, or he has to access, let's say, a password change. So those kind of things you can choose. Now, depending on a predefined policy that you're going to choose, for every policy, there is a JSON format which tells what and all can be done. Okay, because this is what you're applying, and you can see this is a standard policy which allows a particular resources to be created, or this allows the user to have administrator access. This is very wide open. Now, instead of that, let's take a simple one. Okay, so what is that you guys saw? S3, right? So let's say S3 full access. Okay, now if I take this, you can see for this, again, there is a format in which you will be able to tell what are the actions that you want to give and what you don't allow this guy. So here the policy says, give him access to the complete S3. And that is what here you see. The same, if I just change this to, read-only access, then if you just expand, you should see there is some difference in it. Okay, so this is where there are some predefined policies that you can put, but ideally we cannot always use the predefined. You have to use a combination of certain things and you can create your own policy. So this is where, rather than creating a JSON file and entering this, so we can create a runtime content which is equivalent to this, wherein we are not going to create a physical file, but during runtime we will create a source which is only for read-only purpose. Okay, and that is where here in this example, if you see, for any policy that you're applying, you have to define a statement. Okay, a statement decides what permissions to be given and against what resources it has to be given, and if there is any particular filter that you can do, you can allow this. Okay, and it also says whether to allow or whether to not allow. So all those things put together is what we call it as statement. So for a single policy, you can have multiple statements, and for every statement, you are going to tell whether you are going to allow some access or deny some access, and what are those which you are going to allow or deny, and any filter for that. Okay, so this is what ideally a policy will look like for you. Now, if you see in this, now within a statement, the effect tells whether to allow or deny. So here, if you attach, this statement will tell that user has some permission to allow. But what is that? And that is where action comes in. So in the action, you can either say entire resource like S3, then what will it do? Everything under S3, because under S3 as a service, there are many actions you can do, right? So here, if you see in the previous one, okay, just make a note of this. Here you are giving access in the S3 specifically to run some functions or APIs or console, which will get you the permissions to run get and list. Now these are what we call it as reading something from S3 bucket. Now for that, if you have permissions to run these functions, then what you have permission is only to do a read only. So that is where here in the S3 read only, you are given permission to run any commands which will help you to get only the list of S3 or list the existing S3 details. So that is what it is going to do. The same thing if you change this to, for example, full. Okay, if you see, do you see in the action we are just saying S3 colon star. So that means whatever is the functionality within the S3 service, you are allowed to do everything. And that is where here it says it's a S3 full access. So likewise, in the action, you can choose what service you want, and in that service, what particular action that you want. Okay. Now you can also give a combination of different services. But as the name says, it is meant only for S3. Now this is where if you go back and take the default one, which is the administrator, you can see action is star. That means each and every resource in AWS you will have access, and that is where you're going to be called yourself as an admin. Okay, just one small star will give you every permission. So that is where now in this example, what I want to do is when we create a user, I want to give him the access to CloudWatch, which is a service. And for that, I want to give him only read only. And this is where effect is allow and action is, I'm saying CloudWatch describe, get, list. Suppose if I also want to give access to S3 bucket in the same way, then I can also take the previous one action S3 colon get star S3 colon list star. That what will happen? This person, when I apply this policy, has permissions only for read only against CloudWatch and S3 if I add. So like that, actions will decide what is that particularly that you can give access. And then in that, what do you mean by resources? So within this, if you have any specific resource against which you want to tie up, like suppose if you want to say within this, I have a particular username for whom you should be allowing, or if you are trying to display this only under a particular region, I should be allowing it. Or if you are trying to work or set up some policies for a machine, then I will say you are allowed to create the machines only under a particular security group. So that way, resources specifically tells the region, the security group, or the network under which all these things will be created. Okay. So when I say star, so this means it doesn't matter on whichever region the user is going, he will be having the permissions to do the read only for this particular CloudWatch. Okay. So that is how for every policy you will give a statement, and the statement will have three values: effect to allow or deny, action is to tell what is that particular service, and in that what are the actions or the functions that you can do, and resources is more about a combination to which it is applied, like a region or a specific network like a VPC or a subnet or a security group within which you should be allowed. Okay. So tomorrow when we go with another example, I'll just expand this with more. But right now, it's a simple one where it says the user will have only permissions to do the read-only permissions on CloudWatch services. He cannot do anything. Okay. So now, if you look this, we are using a data block, and for this, there is a new data type called AWS IAM policy document. So this means we are not trying to create a document physically, but for runtime, we are going to generate this. Okay. And that is where, once again, for read-only purpose, the data source will be used. So when you execute, the Terraform data source will generate a policy document. It will not generate the policy. The JSON format, it will just create. So using this, we are going to generate a policy. For that, we will use this resource block. So here you can say resource, and we will try to tell the name. And this is the name of my resource, where I'm saying create a policy called CloudWatch read only. And for this, I'm trying to tell to apply the policy. Now to apply, you will say data dot the type and the name of it. And in the end, if I say dot JSON, whatever that it has generated, it will apply. Okay. So there will be a policy created with the name called CloudWatch read only. Okay. So this is one policy that I want to generate. Same way, I want to generate another policy which will give CloudWatch full access. So now watch the same way what I'll do. I'll have another example where I'll have one more resource to create a policy called CloudWatch full access. And for that, the document that I'm giving here is statement, effect is allow, and action is CloudWatch star. That means you will have full access on CloudWatch only. And it doesn't matter whatever the resources, everything. Okay. So now when I run this, what will happen? Terraform will create two policies. One is the CloudWatch read only, and the other one is CloudWatch full access. So it is going to generate two policy. That's all. But now I want to create a user and apply this by deciding on the condition. Okay, and this is where now watch what happens. I'm continuing everything in the same file. Okay, so now what we will do, we will have a new variable block, and in this variable block I'm going to say the name of the variable is give Adam CloudWatch full access. So this is the variable. Okay, now here you can come down. So this is where there is no straightforward if and else, but I'm having two resources which is of the same type, where this is for attaching a user with a particular policy that you have generated above. Okay, so this is where I'm creating a resource to attach the policy. So first is for CloudWatch full access policy, and the second one is for CloudWatch read policy. Okay, now in this resource, when I say attach a policy, so first I'm going to say what is the user against which you are going to attach the policy, and then what is the policy now. So this is where you are going to give the policies ARN, which you will be getting it by the above one. So here, whatever that you have created, right, the full access. Okay, so here this dot ARN, because the output of this policy resource will generate what we call it as a ARN, which means AWS resource number. So that will be a unique number, and that is what I am trying to attach. Okay, now it will attach the user, but this is where I'm going to give a condition. So what is the condition? So watch this. If this variable is enabled and if this is returning true, then I'm going to return it as 1 so that this policy will be set. Suppose if this user variable is not set, then I should return 0. That means it will not at all set the what? The full access. Now this is where we will do the else condition. So the opposite of this is what I'm doing in the else condition. So I'm having the same condition for this resource block, wherein the only difference that I'm saying is if this condition is true, then make this as what? 0. That means if the user you have enabled full access, then I should set full access and not this, and that is where in this place 0 will be written. Okay, but however now if I give this a boolean as 1, that means I don't want full access. So what is the access I should be giving? I should be giving him read only. Then when you come to this condition, this is failable and this will be 0, so that means it will not set full policy. But when it comes here, if this condition fails, I am returning 1, and that is where count is 1 here. So because of that, this resource will get executed. And here, what is the policy that I am attaching? I am attaching the read only. Okay, so with just change of this, you can see I am trying to do a if and else. Okay, getting the logic? What I'm trying to do here, the if and else.
Yes, sir.
Yes, sir.
Okay, so now we'll put together
Yeah.
everything. So we will create a user and we will try to set this. So for it, I'll just put everything randomly. Okay, and I don't need this. So let's try to run. So 1, 2 resources, 3, 4 resources, and then 5th resource, and 6, 7. So totally we have 7 resources. But out of that, only 6 will be getting executed depending on the value. Okay. Okay, Terraform validate. All right, it's perfect. So now all I have to do is Terraform plan and the variable. Now, what is the variable name? So you're going to just say, what is that? Give Adam CloudWatch access. So if I just say Terraform plan, and then here I will say an output file so that I don't want to keep passing it every time. So I'll say plan out file will be, let's say, my plan. Okay, and here we will say variable this and equal to 0. So first time I don't want to give, so I want to give only the read only access. Okay, and let's see what happens. So it's going ahead with what are the resources if you see. So the 2 policies are getting generated. That's the actual resource. And then the user is getting created. And you can see the read only will be getting executed. Okay, because I have given it as 0. Do you see this? A read only. If I give this as 1, you should see the same 4 resources because data source is not an actual resource block, right? So you can see now it is a full access. Okay, so let's try both, and we have generated. So let's go ahead and say Terraform apply, and we are going to say the plan name. Okay, and auto. All right. What is wrong? Configuration path Terraform apply. Okay, and auto approve my plan. Okay, let's just change. All right, so let's go here. Okay, so now let's see, it would have applied full access. Let's go back to IAM. So there's a user, and for this user, if you just see the name, I have given it as full access. That should be good. And if you come down, you can see it has applied the full CloudWatch access. Okay. So that's because of the condition. The same now, what I'll do, just to quickly remove this. I'll go ahead and say destroy. Okay, so it's asking me, which I'm going to keep as 1. Okay, so I delete it. So quickly now let's redo the same. I don't have the user here. Okay, so let's rerun the same now. The first is we do a plan, and here I'll make it as 0. So that means I'm saying don't give full access. So because of that, your read-only policy should be getting created, and that is what we are going to see as an apply. And now for this, let's go ahead and apply this plan. You can see it's attached the read-only. Okay, so now let's go back and refresh. So here we have the read-only. And you can see the different policies applied. Okay, so this is how your if else will happen. Okay, so it's not as straightforward that you would be giving if else, but pretty much it's all about how you define your condition. Okay, so the same condition what we did here, if it is true, then return some value. So based on that, it should run. The same way, if it is true, then it should do the reverse. So that way, if the condition matches, it will do this and it will not run this resource. When the condition doesn't match, it will not run and it will run this resource. Okay, so that way you will be able to achieve the if else condition. Getting this?
Yes. Sir, could you scroll up a little? Yeah, here. So, in this resource block, the name CloudWatch read only, is it corresponding to the
It's
CloudWatch
a
read
name.
only in data
It's a
block?
name. It's a name here. For every
It's just,
resource, resource type and resource name. So this is just a name which I have given. You can give any name you want.
no, I'm asking about the second line, name equal to CloudWatch read only. Is it corresponding to the name given by you in the data block?
Yes. Yeah. So this is the name of the policy. So when you go back here, when you're adding a user, you are seeing this name, right? So this is the
Yeah,
name which I have given. So it's up to you. You can give whatever the name that you want. So AWS has a
okay.
list of default policies, right?
Yeah,
So I was just showing you some time back. Wait, let me show you. Okay. So when you create a user and you attach,
at,
so you see your policies. So these are the names which is already created by AWS. So similar to this, I'm creating something for my purpose. So that is what I'm just showing you here.
okay. So we have made our customized policy, right? For CloudWatch.
Correct.
Okay.
Correct. Others? Did you get this?
Yes, got it.
Sorry.
Yeah.
The data field generate JSON file, na?
No, I'm just, what is that?
Data file will generate JSON file.
The data block will not generate a JSON file. It will generate a runtime JSON content, which will be referred here because it is only for read-only purpose. Okay, so that is what I was telling you. It is just going to generate a runtime content of JSON, not a physical file. Got that?
Yes, sir.
Yeah, can you just try running it and see?
I guess the whole thing is not pasted in the chat.
Or is it? No, you have everything. No? Yeah, it has read only. Yeah, it's there.
All right.
I just paste it again.
Only the first if block has been pasted. The second, the vice versa condition has not been there. 0, 1. It was the opposite of first condition. No, that has I haven't received that in the chat box. Can you even if you can scroll down a little, I'll take it from there. The notepad. Yeah.
I also didn't know.
Yeah, that's it. Thank you. No, no, down. Scroll. The chat might have a limited number of characters to send.
Hey, sorry, I was in mute. I was just talking. Yeah, this was not there, so I just copy pasted this one.
It's perfect now. It's perfect now.
Yeah, I didn't know I was in mute. Yeah, I just pasted this recent one. The highlighted one is what was not coming, so I just pasted that.
Yes, working for both full as well as for read only.
Awesome. So conditions are working both the ways.
Yes,
Okay, cool. What about others?
Sir, trying.
Yeah, yeah, sure. You try.
Hello, Adam. Yeah, actually, I'm getting entity does not exist while running that read-only access, while giving the read-only access. In the Terraform, the
Sorry, what?
apply is getting successful. In the console,
Hmm.
console, I'm getting that the entity. Wait, is it-
I didn't get. What is not working?
it's working now. It's working.
Okay.
Okay.
It is working, sir.
Hey, cool. Others? Any issues? Okay. Anyone else is still trying?
no,
No?
yes, not. No one replied. That's why I said no.
Yeah, you have to stay back until everyone replies. Is that fine?
Yes,
Yes. Okay, cool. So, yeah, if you've tried, you know, pretty much there are a few more concepts. I think we can take it up tomorrow. Okay, so yeah, so there are some concepts, and another most important topic is provisioners. Okay, I think tomorrow should be more easier. So we'll try to cover those topics and provisioners, and post this. Okay, so we'll just discuss about. I mean, provisioners is a little bit, but again, yeah, overall, I think we should be good. Let's see if we can complete it by lunch, and then I think I have a couple of examples more that I have to give you. So I'll just walk you through those examples, and this is where we'll see the whole bunch of new things, like whatever we have seen put together. And then we'll try to run, and yeah, provided we complete these. So I'll just also give you overview on Packer, okay, because that is what your management then has to just give a overview of it. But anyway, it should be another small topic. Okay, I think we should be good for tomorrow.
By tomorrow,
Right.
we'll be able to create entire VPC and server and everything through
Yes, that's more
Terraform.
about just the exact keywords that you need to know. But other than that, conceptual wise, I think most of them, 75% we have completed. It's just a few more things so that we will see it tomorrow. And then, like I said, you take full example, then you will be able to understand.
All right.
All right. Cool. And if there are no further questions, then I'll talk to you guys tomorrow. Okay. And I'll share this also to the same email ID so you can just refer back.
Okay.
Okay.
Sure, guys. Yeah. Thanks for joining. Have a pleasant evening. I'll talk to you guys tomorrow.
Thank you, sir.
Thank you.
Yeah, now, now I do hear a lot of noises. So confident. Okay, just kidding. Yeah, have fun. Have a pleasant evening. I'll talk to you tomorrow then. See you guys.
Thank you, Adam.
Yeah, thank you. Bye-bye.